There we go. So when we talk about persistent storage, the problem is that most people think of it from the Docker perspective. Is they think, well, we're going to run containers on a host, and then we're going to mount storage from the host into, right, the container. Here's the challenge with that. If you can imagine for a second that we've got a cluster down here of boxes, and they've got pods on them. And let's say one of these little red boxes is hooked in to these little orange hard drives. Let's say it's a volume on these systems, right? What's going to happen here when this particular pod right here moves over here? What's going to happen to its access to this piece of storage right here? Anyone?
If it's pods, they should have pod-to-pod communication, right?
Well, this isn't a pod. This is a volume in orange. It's a volume, right? Because we're talking about storage. So if red is pods and orange is volumes, what's going to happen to that pod's access to that volume when it moves to another host?
If it loses access or the volume disappears.
It's going to lose access, and the volume will still be there, right? From a Docker perspective, but eventually someone will delete it, right? Or this host might go away, right? So the problem with all this is that in order for us to this to actually work from a Kubernetes perspective, not from just a container perspective, is that the storage subsystem actually needs to be external to the cluster. So what needs to happen is that your storage system needs to be external. So instead of having and presenting disks that are actually locally attached, what you do instead is you're presenting disks now that are available across the network.
Are the small green boxes storage or pointers to storage?
Yes.
Okay.
That was well said, actually, Paul. It is. They're actually pointers to storage. The answer is yes. Because what happens here is that the storage is actually on another system. It really is, right? And by the way, this is true for every disk subsystem inside of any cloud provider.
So like a NetApp?
Exactly. That's exactly right. Was that Travis who said that? Yeah. Yeah, exactly like a NetApp. NetApp, EMC, pick your poison, right? Pick your storage system. All of the cloud providers do this. They run their drives, that little line connection between the small green box and the big green box, that's iSCSI, which is basically, for those of you who remember small systems interconnect, right? Yeah, is basically a storage subsystem. But like, Trevor, to be careful with that, because Minio is not a mountable system from my perspective, right? Because that's more like an S3 storage, right? That's an object storage. Correct me if that's wrong. Because Minio, I believe, is S3, right? It's basically API-driven storage. You don't mount API-driven storage inside of an operating system. These green blocks right here can be mounted inside of an operating system because it's block storage. It just happens to go across the network.
So this is definitely more like VMware then.
Exactly. That's exactly right. I mean, come on. Let's be clear. All great poets steal, right? So, I mean, right? That's what they did, right? They were like, hey, because that's what VMware taught us, right? What VMware taught us that we should have external storage systems that report back to compute. And the compute can be variable, but if the compute moves around, which is what these pods are doing in red, if they move around, we still have access to the same storage because the same storage is presented to all systems. So what this means is that if this cute little red pod right here that we love so much, I'll put like something here. If this guy over here decides to move over here, he can still get access through this line to the same storage because the storage subsystem is separate, right? So traditionally, and I would say this is every installation I've ever seen of Kubernetes, there's an external storage system involved. Because let's also be clear, like to answer this, if you're running this on premise, who's managing your virtual machines? What software is managing your virtual machines? Most likely.
Kubernetes.
Well, hold
VMware.
on. Wait, say that again, Trevor.
VMware.
Yeah, exactly. Basically, it's VMware, right? VMware is going to be managing your virtual machines. Kubernetes sits on top of the virtual machines. Remember, Kubernetes actually is not a virtual machine orchestrator, but VMware is, right? So just to say this is that all of your traditional data center structures are still going to be in play. The difference is you're going to have Kubernetes on top of it. Now, I know if you're using Tanzu, it operates slightly differently, but it's still actually the same concept. You've got Kubernetes sitting on top of a hypervisor. Point being is that there's an external storage subsystem here, and this is true whether you're in on-premise or whether you're in cloud. So then the real question that you should be asking me is, how does Kubernetes know how to talk to NetApp? How does it know how to talk to EMC? How does it know, like, how does it do that, right? How does it know? And so, you know, the catch here is that there's volume drivers that allow Kubernetes to manage and talk to the storage subsystems. Now, you don't have to do that. Let me just be very clear about this. You do not have to integrate your storage subsystem in with Kubernetes. You could literally just present disks and ask Kubernetes to mount them into the containers. You don't have to like get Kubernetes to like create disks for you. That's called dynamic provisioning, by the way. You can statically provision storage, present those disks out and make them available, and Kubernetes can pick them up. It'll still need a driver for it, but it won't do it on the fly. It won't manage your storage subsystem for you. But like NetApp, by the way, has strong integration with Kubernetes. So if you run Kubernetes on premise and you have a NetApp storage system and you want Kubernetes to actually ask for disks when it wants them and needs them because somebody asked for them on pod level, you can do that. So just want you to be aware that that's typically how this works, is that we are talking about external storage. Now, I said that just so you know, if you're in like a non-production environment and you need to use local storage, like you need to use storage that's not remote, that's not this, and you need to do this, guess what? You can do that. But remember that in a production environment, I've never seen anybody not run production with an external storage system. And if you're in cloud, does it for you automatically. You don't even have to touch Kubernetes if you do it in cloud. It actually just does it for you automatically. It picks up general purpose storage for AWS as an example, and then that's what it does, right? So just know. So I wouldn't necessarily say that Kubernetes is storage aware, but you can make it storage aware by using what's called the right volume driver or storage driver. So let's dive into that a little bit more. Questions before I go forward?
Yeah, this is Mark. Sorry. With external storage and having it in AWS and all that stuff, is it? You said it provisions itself, but it's still like, say for instance, if we're doing malware and stuff like that, and we want our it to be separate, like in a separate VPC and things like that, is it still capable of doing the routing and all that stuff in AWS? In order to, so I guess Amazon has this rule that anything has to do with malware has to be in a separate VPC.
So the EBS storage system that feeds out this in AWS will work in any VPC.
Okay.
Yeah. And while EBS is limited by availability zone inside the VPCs, like if you create a hard drive, it can only work in that availability zone.
Right.
EBS is ubiquitous inside of the region.
Okay, so you can basically access it as long as you're in the same region.
Yeah. No, don't get me wrong. When you create a disk volume, that disk volume only operates in a single availability zone, but you can request from any availability zone in that region.
Okay.
Yeah. EBS is regionally available, right? But AZ consumed, if that makes any sense. You can request it regionally, but you have to operate it inside of a particular AZ. For those of you who are not speaking AWS parlance, just ignore that whole conversation. All right. All right, so let's peel this back a little bit. So the storage methods here are either a container OS file system, Docker volumes, or Kubernetes volumes. But let's be clear, if you're running in production, you're using Kubernetes volumes. You're not using Docker volumes, and you're certainly not using container OS volumes, file system storage, right? You're not doing that. Don't get me wrong. If you mount a Kubernetes volume inside of a container, that container is writing to that volume, so it's using whatever file system is being presented. But you're not using Docker volumes. That should not even be there, honestly. You should not be using Docker volumes in production at all. Even Docker Swarm, by the way, manages Kubernetes to present volumes back to containers. So all that Docker volume stuff that we used before, the concepts apply to Kubernetes volumes, but you're not going to use Docker volumes in production. So there is a file system, by the way, inside of containers. How do we know? Because we can mount disks inside of it. Like the fact that we can even do that means there is actually a file system space inside the container, inside the pod. But as you well know, it's actually just part of the host operating system. It's just isolated. A container's process, memory, and file system space is actually just part of the host. It's just jailed. It's isolated from everybody else. That's all it is. But remember that if you don't add a volume, that whole space is ephemeral. Meaning if that container crashes and you have not added persistent storage to the container is going to crash and you're going to lose all your data. But we already talked about this. You saw pictures on this, right? We know this already. Now, Docker volumes is a way to solve this if you're just using Docker. But again, if you're deploying into production, you're going to be using Kubernetes volumes. You're not going to be using Docker volumes. You're already familiar with Docker volumes because we covered that before. So Kubernetes volumes basically work just like Docker volumes in the sense of that you can have them local on the host. You can actually talk to a remote storage system. You can create cache volumes that are just empty directories, right? Empty dir, right? You can do that. The data, by the way, will persist or wrong restore, but I want to like point out this one thing. It says supports many volume types through volume drivers. That's an important point. Now, I want you to just relax your eyes, pretend that you know a bunch about the subject, read those words there and tell me if you know at least what the first 4 or 5 volume drivers relate to. It's got some key words in there, right? AWS, Azure, GCE. You know what those are for, right? You may not know what the services are. Like you may not know the difference between Azure Disk and File, but you know those are cloud drivers.
Amazon, Microsoft, Google.
Yeah, right. So when you see stuff like that, which like I think the NetApp one says NetApp Trident on it, like one for the Trident subsystem, if I remember correctly. Like when you see these drivers and they're made by a vendor, they contain the name of the service and the name of the vendor usually. Now config map, we talked about before as the one where you actually are taking configuration files and sticking them into storage. That's probably the only other relevant one. NFS can be useful, by the way, if you're just messing around in your local lab environment. So for all of you guys who are messing with Raspberry Pis, NFS is awesome. But I just want to point out that like things like Minio and Ceph and Rook can also be extremely useful. Those are open source projects that mimic either object storage or block storage. Just know that there are a ridiculous number of options. Just know that Rook and Ceph are owned by the CNCF. Well, Rook is, hold on. Is Ceph owned by the CNCF? It might be. Anyway, point being is that those are rock solid open source projects that allow you to present storage. And there's also OpenEBS, by the way. OpenEBS is a mimic of EBS inside Elastic Block Store inside of AWS. You can actually run your own iSCSI systems if you want to. Again, your mileage may vary. But the main thing you need to know is that of these that you externalize the storage system, it's the first 4 and NFS. The rest of these are local or they're inside etcd, right? Because when we created a secret earlier to mess around with authentication, that secret was stored in etcd. We create a config map, that config map is stored in etcd. So don't consider those high performant file systems. Only the ones that are remote or the one that's local, and assuming you have a fast local disk, they're the ones that are going to be super performant. Now, they go through and start talking about the difference between Elastic Block Store and AWS and Azure Files and persistent disks. No, unless you already know the cloud inside and out, this is not going to be useful information to you, right? But just know that it's here. And if you're interested in learning more about this, because you're like, hey, I need to know more about this, you can literally go to the Kubernetes documentation and look for, is it volume drivers or is it storage drivers? I can never remember. Oh yeah. The container storage interface. That's what we need, right? The container storage interface, by the way, also notes that this is like, there are standards for how these drivers are written, right? So just wanted to make sure that's clear, is that like the container network interfaces or the container runtime interfaces, There's a standard for how this storage runs. And remember, I mentioned before, there's two modes, dynamic provisioning or static, like pre-provisioned or static provisioning volumes. Static provisioned or pre-provisioned means that you make the volumes first and you say, here, pods, I have made a series of 4 GB containers for you to consume. Dynamically provisions means that if you decide like you're using like dynamic provisioning, that the pod can just ask for what it wants and it will get the exact size that it's asking for. So if the pod comes in and says, I need a 1 gig file system, you get a 1 gig disk. You want a 4 gig file system, you get a 4 gig disk. So these volume drivers that are part of the CSI, this container storage interface, if you set it to dynamic, it means that it's going to make it for you at the time that you request it. Let's see, that's not what we were here for though. We were looking for volumes. All right, so several types of volumes listed here. Here's an EBS configuration example. Notice that this is a pod that has a volume attached to it, and it is mounting the AWS Elastic Block Store, right? So note that you can specify that inside as well. So there's a bunch: Azure Disk, Azure File, Ceph. I mentioned Ceph before. I know that sounds weird because it looks like Kef, but it's Ceph, right? Sender is another one that's open source. This is made by OpenStack, right? Which is, I think, originally a Red Hat project. Config map we already talked about, which we're going to talk about more. Empty dirt, we're going to talk about the rest of these. Fiber channel, because maybe you're old school and you got storage, like you got a fiber channel, you got a SAN network, right? Although I will tell you, most people don't use that. They use the vendor's driver, right? GCE is there. Let's see, was there anything else here that I wanted to make sure? Oh yeah. You used to be able to mount Git repos inside your system. That was an utter disaster, by the way. The performance of that file system was absolutely horrid. So as you can see here, what are they doing? They're deprecating it, right? Yeah, they're saying use empty dir instead, right? Gluster is a shared file system. Host path is local storage. Anyway, my point being is not to actually have you run through this whole thing because I'm just scrolling past it, so who cares? But like, just so you know that like there's a bunch of options out there and you can actually write your own options, okay? You could write your own driver for storage if you wanted to, okay? All right, tons of options. Okay, so let's talk about the ones that are not related to external storage systems, not VMware, not cloud. Just know that you can hook Kubernetes into an external storage system using these volume drivers. That's what you need to know. Let's talk about this though. So config maps, we mentioned this before, is a way to create key values that are mountable. And this is why they're under storage, by the way, because they're mountable underneath the container. You can put them underneath the container. They mount inside like a file. So we were using this to create config files, right? At some point. So, and you can create a config map by just like defining a key value, or you can use a YAML file. So look at this. So this is a pod definition. It's got a container spec, right? And it's basically mounting a volume mount with the name is config, and it's mounting it on etc config. Now, where's the volume? Oh, all right. Don't do that. No, so notice this, the name says config. Notice that it's set to read only, and it's going to mount it at etc config. Now that's just an example. You could do whatever, etc Elasticsearch, whatever, right? Notice that this name right here refers to this volume name. That's the linkage between those two sections. Is that the name under volume mount that says config is referring to that volume called config. Now, then what it does is it defines what this volume is. What is this volume? It's a config map. What's the name of the config map? It's my config. Where did that my config come from? Well, let's go back up here. See where it says my config? And here we are creating a config map. That's what we're doing. Is we've created the config map first, and then what we're doing is we're going into the pod definition and we're basically defining it as a volume, and then we are mounting it at etc config. So first we created the config map, then we defined it as a volume, and then we're going to mount it at this location. Is anyone not following that? Because if you are, I'll gladly explain it again.
So I'm following, I'm just, I wanna like, so you're mounting it inside the container or what?
Yes.
Okay,
So inside the containers file system at etc config,
gotcha,
the application can now read that as a config file.
gotcha.
Yeah. It's very useful, by the way, because no one has to see those configurations except for the administrator. Because the developer can just give it to you and give you the configuration spec, and you can just define it as a config map. And you could change the config map based on which Kubernetes cluster they're running on. So for example, if they're on the dev cluster, they might get a different config map than they might get if they're on the production cluster. You might think, well, why would I want to do that? Well, because then you've got a very generic pod that can be run anywhere, and it will change its behavior based on the environment that it's running in. By the way, this is exactly how secrets work. Secrets are mounted inside of a file system. You can read them at boot time, get your username and passwords, and go on. When I say you, I mean the application, right? So this way you don't have to put your credentials in repo anymore, right? Just put them inside a secret, let the application boot. The developer never sees it. The only person who ever sees what's in the secret is the person who creates the secret. That's it. And by the way, you can give it to them base 64 encoded if you wanted to. Now, don't get me wrong, they can easily decode that. But like at a glance, they wouldn't be able to guess the password, right? They'd have to go reverse decode it. So secrets work the same way. The only difference is that config maps can actually represent entire configuration files. Secrets usually are like just key values, username, password, database username equals this, database password equals this. They're usually just key values. They're not usually like whole config files. Now notice here, what they did is they applied this YAML file down at the bottom. Then they logged in to the container using bash. And then they catted from inside the container this file. And what did they see? They saw what we put into the file earlier. They saw that. So this allows your application to parse these files and just use them. It's just that simple. Other questions? Okay. Let's see. Empty dir allows you to basically create I wouldn't say it's like persistent because it's just a local loopback, but it allows you to hold temporary files, right? If that pod, by the way, switches nodes, you lose the empty directory. So just so we're clear, nobody does this anymore unless there's a very edge use case. So this is just here so you know that it's available. But you can use it to centralize to have people write to the same thing, but there's other ways to accomplish that. So anyway, so by the way, when the pod's removed, let me make sure this is super clear. That empty dir goes away. If it moves to another host, that empty dir goes away. Okay, so this is really just for caching. Like if you're like, hey, I don't want you to write into var live Docker, I want you to write into something else, you can actually could control it that way. Here's the specification for empty dir. This is actually useful just to see the volume mount and the volumes again. So notice the volume mount's the same. By the way, this is going to go in /cache, right? Notice that the name is cache volume and that it defines its type as empty dir. And there's no other information there because that's all you need. It's a cache volume. That's all it is. It's a scratch file system. That's all empty dir is. Host path, by the way, basically mounts, like, how we were mounting local file systems into the other system. You can do that. You can use an NFS volume. You can use a local volume. So for example, if you have a really fast disk attached to your system and you want to mount it inside of a pod, you can do that, right? So when you run on AWS, if you decide to use what's called instant storage, which they recommend that you don't do, because if you lose your virtual machine, then you're going to lose the instant storage because it's tied to that host. That's what a local volume is. It is typically fast storage, but the cost of it is that it's ephemeral. It looks like it's going to be permanent, but it's not. The only way to get permanent storage in Kubernetes is to use an external storage system. So this is your NFS, your EBS, your Azure file and Azure disks, NetApp, EMC, whatever you're using. Now, here's a little bit of trickiness around this. In order to get a persistent volume, which we were just, this is what we were just looking at. Everything we just looked at was a type of persistent volume, meaning a volume that is attached to a container or a pod in this case, right? In order for you to get a persistent volume, you have to have a persistent volume claim that says, this is what I want, right? I want this. And so what happened is a pod uses the claim to request basically a disk from Kubernetes. So it says, here's my ticket. I want a 2 gig disk. If the disk is pre-created, Kubernetes will just give it to you. If the disk isn't pre-created, what will happen is that the claim will go to the storage class. So see the storage class right here? Because when you make the claim, you say, look, I want NFS storage. When I make the persistent volume claim, you say, I want NFS storage. I want 2 gigs. So the persistent volume claim basically makes a request against the storage class, who then basically creates the volume and presents it to the pod. Is that confusing? Let me say that again. The pod has a ticket, a claim, says, hey, I want 10 gigs of storage. It then talks to the storage class, who basically says, I'll give you a disk. I'll give you a persistent volume. And then it gives it to the pod. And for the life cycle of that pod, that storage is there, right? By the way, even if you delete the pod, and if you've set it to retain, if you delete the pod, the disk is going to stay there, just so you're aware. Just so you're aware, the persistent volume is actually presented to the host node. So if the pod is on node 3 and it moves to node 2, what will happen is that when it moves to node 2, the storage will be depresented and then presented back to node 2, just so you're aware. Because every node in the cluster has to see the storage system. So the storage system will actually move its presentation of disks depending on which pod it's chasing. I know. Aren't you glad that you don't have to do this manually? Aren't you glad that Kubernetes does all this for you? Isn't that great? It could be so much worse. I can't imagine what these guys were doing back in 2008, 2009 before they released Kubernetes for the public. You know, I know that was like 6 or 7 years later. Because just so you know, they wanted to release it back in 2009, but it was so complex that everybody they showed Kubernetes to back in 2009, they were like, absolutely not. We cannot even use this. It's so complicated, right? And so here we are in 2015 when they first released Kubernetes, and it's still actually pretty complicated, right? All right, so we're gonna walk through the whole claim, volume, pod thing again. So just stick with me for a second. So first, you're gonna make the claim, and then if you don't have dynamic storage, you're gonna have to make the volume. And then when you have that, then the pod's gonna like get assigned the volume at that point in time, right? So K8s is gonna detect that you have a claim and a volume that are related, and it's gonna bind those the requests together. And then it's gonna basically associate that persistent volume with that pod for it to use. So let's start with the claim. The first is the ask. You got to ask first, right? If you don't ask for what you want, you don't get it. They might still say no. So here's the persistent volume claim. Notice the API version is 1. The kind is PVC. Here's the metadata. Notice that it actually lists the storage class name. Local storage. It lists a mode, read write once, which means that only one pod can request this ever. After that, I think it's destroyed. What's the size? What are they asking for in size? 1 gigabyte, right? Or gigabytes actually is what they're saying. So we assess the claim and say, look, this is my claim. This is the driver I'm going to use. And this is the size that I need. And if there's any other access mode policies or retention policies or whatever, they're all going to be listed here, right? So I've asked for 1 gig of storage from the local storage system. Now, then we come down to the actual persistent volume definition itself, because we've made a claim, right? And so what's happened is that we're saying, hey, I need a local volume. I want it to be up to 2 gigs in size, right? I want it to, oops. Oh, sorry, that went forward. I want it to be a file system. Here's my access mode. I want you to, if the pod is deleted, I want you to delete the storage. I want you to use this local storage path, and I want you, here's the path to the local storage that I want you to use. So that's a reference to a particular disk, right? So what's going to happen is that this has a 2 gig capacity. And up here, we're only requesting 1 gig of that total capacity. So a portion of that disk is going to be presented back up to as the file system, right? It's going to be jailed, right? They're going to present only a portion of that file system back up to the system. So this defines 2 gigs of local persistent storage on the system. So now we've got a claim of 1 gigabyte, and we've got an available volume of 2 gigabytes. Then the pod comes in and says, you know what? Here's what I want. I want some LPV, some storage. I want and here's my persistent volume claim, LPV claim. That name for that LPV claim matches the claim that we just looked at. And then here's my container. Oh, and by the way, here's my volume mount. And here's the volume. So what this is going to do is it's going to request the storage using LPV claim and make it available at the mount point. So the only linkage in this entire document with the PV and the claim, the PV and the PV claim, is this.
What if you have a pod that's already existing and you want to add storage? Could you just edit the YAML file, like add these sections and then reapply?
It depends on the storage subsystem, right? Because not all storage systems allow expansion, but like all of the cloud providers allow you to expand the disk on the fly. As an example, I think NetApp does as well, right? I haven't touched EMC in a long time. I know it did. I don't know if it does with Kubernetes, right? So expansion is not really an issue. So to make sure this is clear, you're making a claim against a particular storage system for a particular volume. And then what happens is the pod comes in and says, this is my claim. And the claim is the linkage between the storage class and the volume that you're asking for. What's the claim? The claim is the ask. What are you asking for? We asked for 1 gig in this case, which talked to the storage class, but we had actually already created a 2 gig volume of local storage. So what will happen is that 2 gig volume is going to get sliced up into a gig, and it's going to get presented and mounted inside the pod. That's what's going to happen. That's it. So that's how persistent volume works. So you need 4 things really. You need the persistent volume claim. You need a storage class defined. You need a persistent volume if you're doing static definition. If you're doing static provisioning, pre-provisioned requests, you have to define your volumes first, and then the pod has to ask for the claim. The pod asks for the claim. Let me say this one more time. The pod asks for the claim. It's the claim and the pod are linked. Everything else goes off the claim. That's how the storage class gets found, and that's how the volume gets found, is through the ask, the claim. Okay, so just remember, pod asks for the claim. The claim defines whether it's going to get dynamic from the storage class or whether it's just going to grab a volume from the storage class. Okay, so pod to claim to storage class to storage. Okay, hopefully that's super clear. So even though that they said that it had to be created in that order, you could actually create the storage class and the pod first. I'm sorry, the storage class and the persistent volume first, then make the claim, and then make the pod. So, and that's because that's the order of events, is that the pod's going to look for the claim, which is going to look for the storage class, which is going to look for the volume. So that it doesn't matter, right? So remember, pod to claim to storage, class to storage. Okay. Secrets we kind of talked about already. So I'm not going to dive into this because I'm kind of wanting to get it, see if we can get the lab functioning, right? Creating secrets from a file, which we did that, right? We were just messing around with that when we did that JSON file for config.json. We actually just specified the path to the file and we created a secret with it, right? It was that big old command that like that kubectl command that we had inside of chat. Anyway, what did I just do with that thing? Here it is. No, not that. Here we go. So this command right here, right? kubectl create secret, a generic secret. Here's the name of it, from a file. We set the type equal to docker config JSON, of which there's only like 6 or 7 types, right? Of secrets. But the docker config JSON is actually a type that you can actually set. And Kubernetes knows exactly how to handle this because it actually is built to store the docker config JSON. That's why there's a type for it, because it understands that you have to authenticate to different registries, and this is how you would do it, right? But it's just that simple. Sorry, was having a moment there. So here we are again, kubectl create secrets generics. Here's the name from a file. We did this, we did some of this already, right? And then you can actually export out the JSON or the YAML or whatever. If you want to see what it actually did with it. You can also create secrets on the command line. Generally files are preferred, but whatever, it's all good. So here they're actually saying from literal and then another from literal where password equals whatever. So. Here we are using secrets just like we use config maps, is that we have a volume mount. Here's the name, the DB cred volume, and then it's specifying like where it's being mounted and all this stuff. This DB cred vol refers to this. The secret name is that. So we're using image pool secrets a little differently because we're actually just using that as part of our image pool. We're actually not mounting, you know, our Docker config as a file. We're not doing that, right? We're just mounting it. I'm sorry, we're just reading it at image pool time. Notice, by the way, here they're catting the actual secret and it's returning the, notice that they're catting user ID and that's returning jane@abc.com. So this key that gets defined up here, user ID with Jane, you can literally cat that as a file. We're literally catting user ID, which was the key that we inserted inside the config map. We cat that, and guess what we get? We get the secret. So every key you stick in a secret shows up as a file in the file system if you mount it. Every key that you stick in a secret on the left-hand side shows up as a file on the file system, which means you can cat it to get the secret. You don't, it's super easy to read, right? You just hit the right path and you get the secret. Okay. Questions about secrets before we go over just security context, which is the last thing before we roll into a lab. Okay. This is just for you to be aware of. This is literally like just a couple of pages, right? That's it. Ideally, when you run Kubernetes and you decide to go in production, you're going to want to grab either the CVE, not the CVE, the, oh God, I forgot the name of it. The DoD just released a hardening list for Kubernetes. I need to pull that thing up. So we need to basically harden Kubernetes because there's certain things you don't want to do with Kubernetes. For example, when you are isolating these containers, you don't want them to run as root, because guess what happens if someone breaks out of the jail? They're going to be running as root. That's like saying that you're going to put a prison inside the royal palace, right? So that if someone breaks out of prison, you know where they're at? They're in the royal palace, right? That's not what we do, right? So when you do run as user and run as group, by the way, what you're doing is you're changing the way the pod and subsequently the containers are running. So they're not running as root. For example, if you're using OpenShift, by the way, OpenShift won't even let you run a container that requires root access. You have to run a container as a user that is jailed, right? This includes, by the way, file systems, other Linux capabilities. You can also set things as read-only. There's a couple of options here. And what you're going to do is I would get, and I see if I can dig it up. I actually will put it in the email because I just got a fresh copy of it. But you can, I will actually attach the hardening guide to the email that I send to you either later today or tomorrow morning, so that you can actually get access to the hardening guide that the DoD just published actually on Kubernetes. So, but just note that there's a bunch of options here that need to be changed in order for this to work. So for example, let's say you design a security context and you want to add it has a pod specification. You just put it in the same spec where you put your volumes and your containers. And this allows you to run the containers as a particular user ID to isolate them down. This works very different from just like running plain old Docker, right? Because this is going to be much more jailed than just like the Docker isolation. So as an example. Oh, that's awesome. Thank you, Trevor, for posting that. Because I had just gotten it the other day and I was like, huh. Yeah, the CNCF design reference for DevSecOps. That's great. And then the STIG. Yeah, there it is. Good. That's perfect. Thank you. Thank you for posting that.
What does the 1,000, 2,000, 3,000 mean? What was
Oh,
that?
those are user IDs.
User IDs. Okay.
Yeah. So if oh really, did I close that? That's weird. Actually, you know what? Probably better to just do this in the lab. So just so you're aware, well, if we're out here and if we look at like what the way Linux works, if we actually cat etc users, hold on, am I drawing a blank here? Actually, I'm going to cat etc group because I think I'm drawing a blank for whatever reason. See all this? This is actually user. These are groups that exist inside the system. They each actually have a unique ID. And for some reason, my brain just completely failed about the file that actually contains users. It's in etc, I know that. And then it's is it not users? Oh my God, I can't believe I can't remember that. That's like a basic thing.
Pass WD.
Sure.
Wait, say it again.
Pass WD.
Oh, thank you. Dang it. Really? Man, what was I thinking? Oh my God. Anyway, yes, password, etc password. So etc password is where all the users are stored and they all have user IDs. So when you specify a number in there, you're actually specifying what user ID and group ID that you're using. So if we go back to our example, I love how that works.
Got it.
Yeah. Did Windows just go belly up on me? Weird. What we're doing is that when we say 1,000, we're actually picking a user ID off the host system. If we say 3,000, we're picking a user ID off the system, right? So just know that all of your host systems, and this is where Ansible still comes into play, by the way, right? Is that all of your host systems have to have the same user, numeric ID and name, right? And group ID and name. So just so you know, all of your Kubernetes nodes need to be configured identically, because if there's a deviation, you better believe this thing's not going to run. If it goes on a host that doesn't have a user ID that it can use, it's going to fail, right? So, but that's what that is, Paul, is different user IDs and or group
Okay.
IDs.
Thank you.
Thank you, Trevor, for reminding me of fundamental Linux administration. I can't seem to remember it.
I have another slightly off-topic question.
Oh, hold on,
I'm
hold on,
just-
just 1 second. Let me just make
Oh,
sure.
yeah.
Hold on,
Go ahead.
just 2 seconds. Okay, so you add the context, and that changes the context by which the pod runs. There's a 1,000 other things that you can do here. What did I say were the 2 hard topics in Kubernetes? Networking and what?
Volumes?
No, storage actually isn't that hard, but good guess.
All of it.
No,
Yeah.
networking and security. Networking and security are the 2 harder topics inside of Kubernetes. Okay, that's it. That's all storage. We just covered that whole thing. So what we're gonna do is we're gonna roll into the storage lab. Let's see. Brian, you asked a great question. Any guarantees on the lab? Well, there's no guarantees on the lab, not at this
Yeah.
point, right? But we haven't touched it for a minute, so we probably got really unblocked, right? So, and since this is more of a storage focused lab, hopefully whatever we're using has already been cached and downloaded, but no guarantees, right? I do actually have the beginnings of at least the basics of a script. So for those of you who haven't actually set up your secrets yet, or for like, I know that like a couple people didn't get it to work. We can actually try, I can share these commands and you can just do this really easily, right? To actually get this started. So, but that's what we're going to focus on next is we're going to take another swipe at the labs. If this doesn't work, I promise you, this is the last lab in which we'll touch the lab environment. Right, if this went forward, we'll just stick with Katacoda labs and just get that to function. But I don't have a Katacoda lab for this. Otherwise, that's what we would do. So, okay. So let's go take a look at the lab instructions and let's go see what we're at least supposed to be doing. Because we only got 2 sections left. So just to mention, you are going to start as WAS admin per the instructions. The rest of this, as far as stopping and starting and deleting, please ignore that. Your Minikube instance should already be up. So you don't need to start another one unless you decided to delete the last one for some reason. What you're going to do is you're going to create a little bit of YAML. Notice that this is actually going to pull Nginx latest. So if you pulled latest, you should be fine. This is already being cached for you. You shouldn't be pulling fresh images down. You already got it, right? If you didn't, yeah. So here what you're going to do is you're going to define a pod YAML that basically has the caching volumes in it. Then you're going to apply the empty dir pod, get the pod, right? And then log into it and just list the current directory. List the contents of cache, put a file in cache, right? Just check the contents, and then you're going to delete and recreate the pod and see what's there. Okay. So what should happen is that the cache dir should actually be empty because you restarted the pod, which means the empty cache dir is now gone. But it gives you practice for creating a cache directory. Now, that's all empty cache. After this, what you're going to do is you're going to create a local storage type volume. And you're going to create the volume claim first, right? Then you're going to create the actual volume itself. That's what you're doing here. Then you're going to come in and you're going to create a directory for the volume in the Kubernetes node. So you're going to like SSH into your Minikube instance and just kind of like make sure it's all functioning. And then you're going to create a pod. So you got the claim, the volume, and then the pod, which you're actually going to define here. Now, just to be upfront about it, you're not creating a storage class because the storage class is created by default by Minikube. So you don't have to define a driver or anything else because Minikube already defines a local storage class. And you're going to add a file to the persistent volume, restart the pod, and you're going to see that your file is still there. You can check for the file afterwards. You're going to find out that the file is actually still there. And then you're going to recreate the pod, the claim, and the volume objects, which are already there. You're going to execute in, and you're going to see that your file is actually still there and available. Okay. That's it. So we're just going to mess with an empty dir setup, and we're going to mess with a local volume just to give you a taste of it. It doesn't work much different for any of the remote storage subsystems. The only difference is the storage class. You usually have to define it. But like if it's on AWS, the storage class is defined for you already. Okay. So with that in particular is lab 11. We're gonna take a shot at it. The only problem I can foresee us running into, other than, syntax and whatnot, is just that for some reason, you're still getting rate limiting on downloading the Nginx latest. Okay. But let's go as WAS admin and we're good to go.
Can you bring up your text, the script that you were writing? So when you log in on 3, it places it in the user's directory in the .docker folder by default. When we reference it in line 10, in the Docker config JSON home WAS admin, what if we just referenced it in the .docker folder instead of having it at the root? Line 10.
I get you. Right. But we have to pull it out of root because it's owned by root.
Not if you're not in root. So as WAS admin, when you do a Docker login.
Yeah,
it
but
puts
have you tried that?
That's what I'm doing. I don't know why that just caught my eye.
Yeah, the reason is that those systems, for whatever reason that we're using right now, don't allow WAS admin to access Docker.
Oh, I added WAS admin to the Docker group.
I did too, and it didn't work for Paul when we did that earlier.
Hmm.
Yeah, it failed, actually. So that's why we
Uh,
reverted back to this method, because for some reason, when we did that earlier for Paul, it didn't function.
Got it. Okay.
Yeah, that's why. Otherwise, you just add it to the Docker group. I don't know if you saw me, but I actually tried it in front of everybody. And for whatever reason, even though that's worked in the past easily, it didn't work actually. So I was like, forget it. We'll just do it this way. Right?
Okay.
Yeah. Because those were, and it's a setup problem, right? Is that the system was set up to only allow Docker access to root, but you can only run Minikube as WAS admin. Weird. So.
Michael, I got a problem on page 82.
Sorry, Mita, I didn't hear you there. Can you repeat that?
Yeah, on page 82.
Okay.
Step 13. So I deleted empty dash directory.pod. So I deleted that. Now I'm recreating it. After recreate, instead of like the pod was created, I get configured message. And
Show me your screen.
sure.
Oh, sorry, Brian, I didn't see you.
Can you see my screen?
Yes.
So maybe did I made any mistake? So instead of say it's created, it says configured, and then I get image pulled back off.
Okay, so just to mention this, you might want to scale back your replicas for scalar deployment, or maybe kill them, because you're actually out of resources if there's limits involved. So just one thing to mention, just as a sidebar, that probably isn't going to become a factor unless you have anything else that has any kind of limiting. Now you're getting image pull back off, and I'm assuming it's because you don't have the Nginx latest already on your system. Is that correct?
That's right.
Okay, because like that's interesting. Hold on, let me think about that for a second. Okay, so if you describe empty dir pod, what does it say?
What I need to do.
Sorry, say that again.
What? How I'm going to do that?
kubectl describe.
Oh, okay. That's it.
Sorry, kubectl describe, and then you can type in pod and then empty dash space empty
Okay.
dash dir dash pod. But yeah, we want to see exactly what's the problem is. I suspect it's just rate limiting, but that's it. Looking good. Good.
That's it.
Press center.
Do I need to sub YAML?
No.
No.
Huh? Huh. Okay. That's not.
I just did it, pointing to the .docker, and it worked for me.
I'm sorry. Who is that?
Trevor,
I'm sorry. What? I apologize. Can you give me more
This-
context?
the script that I was just asking about, I just changed my path instead of looking for it in the root of the user to reference the .docker.
That's okay.
Agreed. But Trevor, sorry. Let me explain that again because I don't think you understood me. The Docker login command does not work for anybody unless they've been added to the group, the Docker group. That's the way we usually solve that. But for whatever reason, it wasn't working for at least one person, probably more. So that's why we ran it as root, and they were pulling it from root because it wasn't working for WAS admin. So I just want to be careful with that because there were a bunch of people that didn't work for, which is why we fell back to using root. So I'm glad that worked for you, but I just want to make sure we're clear is that's why we were using root, because it was definitely working for root every single time, but it wasn't working for WAS admin, even when we added permissions to the Docker sock in there. That was the mystery, right? Does that make sense?
Yeah, whether or not it was the account. Yeah, I get it.
Yeah, it was just weird, honestly, because that's the way I've solved it every single time. Okay, so you're getting image back off. I would assume, wait, scroll down a little bit more.
Up or down?
Down, please.
Sorry.
It's not saying that you're getting rate limited. It's just saying you got an image pull back off.
Yeah.
Can, I don't think you can run Docker, but can you run Docker for me? Docker images?
What's the command? I'm sorry.
Docker space images?
Thank you.
Yeah. Actually, you know what? This is a good test. Let's just test this because I think it'd be interesting to know if this just works in general. Do me a favor in sudo space gedit. Because I think this is like speaks to the question that Trevor and I were just trying to figure out, right? Take the dash off the gedit, by the way. Okay.
So for the var sock, var run sock, just the workaround for that is just to change that to 755.
And yeah, I always feel bad about doing that as well, right?
I know.
But yeah, we can do that. Yeah, that's actually a good point. That's another way we could work around it. I always feel weird doing that, but like because it's such a permission violation, but that makes sense. All right, let's just do that. So let's see if that can work better. So do a sudo and then do a change own instead. So let's back off gedit because that's gonna cause some. That might be easier. So backspace over gedit. and do a CHOWN. Wait, sorry, CHMOD. Sorry, I confused that. CHMOD. I apologize. I was mixing things. Yeah, type in 755. That's fine. You can leave that. I don't even care. Space /var/run. And then, sorry, /var /var.
You said var, right?
VAR, yes. /run /docker.sock.
Docker doc?
SOCK. Paul, I would check your syntax. That's what that indicates, basically. Let's see, sudo change mod 775 /var/run /docker.sock. Press enter. It'll ask you for the password for WASadmin. Okay. Let's see, we can modify this. Bear with me 1 second. Okay, so let's do. Let's do this. So I'm going to paste something in chat, Mita,
Sure.
and I'd like for you to just paste that in if you can, or you can type it, whichever you prefer.
I'll type in.
Yeah.
Okay, so I'm logging in as here now.
Yep. That's actually easier to type than most people think, so.
Is the permission denied?
I'm right there with you.
Yeah, so this is the thing we ran into earlier, right? Even after changing permissions and changing the groups, it still didn't actually allow Docker to run as WASadmin. Trevor, did you change anything else other than permissions?
That's what I was looking at. Can you do an ls-al on that var run docker.sock file? See who the owner and group is.
Because then you probably put it into Etsy group, right?
I added the WASadmin to the Docker group in Etsy groups, yes.
Yeah. So that's probably the missing piece. All right, so
So, but this is like really scary exercise because somebody who does not have experience, or we are missing so much, right? And doing all these steps is more confusing. It might be just me then.
sorry, Mita, was there asked there? I apologize.
And like,
I hear that you're frustrated.
So I understand it's easy like to have it with me, like, okay, like if I want to create a cheat sheet, so it's easy for me, like, okay, these are certain steps I have to take. But somebody who has a lot of experience, it makes a sense they know how to manipulate. The person like me doesn't know how to manipulate. Or I don't have a hands-on these things at this time.
I hear you. And I think this is part of getting the hands-on, right? Because like
Absolutely.
I'm not this is not meant to be denigrating or disrespectful at all, but this is basic system administration, right? So
Right.
what we're manipulating is just basic file permissions. And you're right, you shouldn't have to do this. Let me just acknowledge this right now. You definitely 100% shouldn't have to do this. I'm just trying to unblock you so we can get the lab going for you. And I'm sorry.
No.
Yeah.
I'm just saying, like, I didn't join this class because I have experience. This is something I want to see where I want to be, right?
Yeah,
So
yeah.
this is pretty good. It's just like if I had the clear-cut instructions, it would make it much easier to follow and see where I get stuck, where I make mistakes.
Yeah. And I think the labs typically work flawlessly. And what we're
Yeah.
doing right now is we're having to explore, which means there are no
Sure.
clear-cut instructions because we're trying to figure it out.
No problem. Thank you.
Yeah, sorry. Would you be willing to try one more thing? And I think we'll probably be like maybe 2 commands away from being there.
Yeah, sure.
Yeah. So do a sudo space gedit, which was the thing that I think we were also doing earlier. And then space / etc etc / group group. And then the WAS admin password. Good. All right. Scroll down to the bottom of that file. There should be a Docker group right there.
Docker root.
Oh, you've got to be kidding me. I'm sorry. I should have said that out loud. That's different than even the one that I looked at with Paul earlier. Anyway, Docker root. If you could like after Docker root, if you don't mind putting
No,
WAS.
keep scrolling down.
Oh, you're not at the bottom?
You should have more users.
I don't have any more. Let me.
I've got a Mongo user, Docker, and Jenkins.
Okay,
Oh.
there you go. Yeah.
Sorry. Thank you.
There you go.
Thank you.
Thank you for saying something. That was like interesting.
Were you gonna add the WAS admin to the Docker group?
Yes.
Yes.
Yeah, I did that via the command line. It didn't work after that.
Did you change the permissions on Docker sock at the same time?
I did not.
Yeah, you need both.
I was
Actually.
looking at the file that we had on the Docker sock, and it looked like the owner was root, but the group was Docker.
Right. So you need to add the WAS admin to the Docker group and
I
then
did
change
that.
change the permissions on the var run Docker sock file.
Okay.
If you change them to like 775 or 755, it's whatever, it's fine.
Yeah, they're already 755, and then after that, I tried to do Docker images, and it still wouldn't execute.
Okay. Yeah, try. I think we changed it to 775. So let's see. So go up to Docker.
Oh,
Yeah,
okay.
see, yeah. See, this is the problem, right? It didn't work. It didn't work earlier when we did it with Paul either, right? So after Docker, put a comma and then put WAS admin.
Yeah.
Yeah,
no.
right after Jenkins. That's perfect.
Okay. Come on and WAS admin. That's it.
That's it. Just save it.
Wow. Okay.
Okay, and so now just run that same Docker login, like arrow up until you see that Docker login -u command again, just to see what it does. Yeah, press enter.
This is one.
Yep, still the same problem.
Denied.
Yeah, so this is why I had it the other way, because it doesn't seem to work no matter what we did. Okay.
So
Back to-
this we tried with 775.
yeah,
Right?
we did it with 775, which basically grants the group owner basically rewrite execute permissions.
Right. And that
So-
didn't work for us.
It didn't work.
Okay.
So
Nice.
I was
Yeah.
gonna say, bless you.
Yeah, 777 works. I know we shouldn't do it, but
okay, well maybe we'll give that a shot then. All right, so is that why you were laughing? Because that
yeah,
just
it
that
was.
just
I
feels
didn't wanna
wrong.
do that. That's a last resort, but
Yeah, let's do it. Okay, so scroll up
Don't
to your
let any Russian hackers break into your lab environment. I think we'll be okay.
indeed. Scroll up for me, Mita, to where that change mod, the chmod command that we ran before. So press up arrow until you see that command show back up again.
Oh, you want me to run here?
Yep, just scroll up until you see change mod once again. There it is. So change that to 777. I feel weird even just saying that, honestly. And you know, like it's interesting, like it worked on Trevor's machine, didn't work on this machine. So weird. Press enter. Okay, now scroll up twice with the up arrow, like just up arrow twice, and then press enter. Okay, all right. Now, since you did that, this other command, this kubectl create command should now work. One that I just posted in chat. And I believe that's edited properly. Docker config.json. Yeah, so it should work.
Okay.
So that command will actually create a secret, and then we will be able to do our final step, and you should be working. So, yay.
You said, okay, I'm gonna try to cheat now how everybody else did it, copy to Notepad and take it from Notepad.
Perfect, sounds good.
Let me try. Okay, thank you.
Yeah, and then, so once that happens, just remember that you're gonna need to update that empty dir YAML that you created.
Sure.
And you're gonna have to add this to the bottom of it.
Oh, okay, got you.
And that's the last step. That's it. At that point, it should be working. At least it worked for almost everybody else. So, Trevor, were you the one last time where it didn't actually work and you were scrubbing the whole system from scratch
Yes,
and it still didn't work, did it?
it didn't until I just, did that the last time. I ran that kube create secret and it said I already had it. So I deleted the secret again, reran it. So that command actually created it in the correct path.
Mhm.
And then it worked.
Okay. Well, in that path, it actually pulls the file into etcd. So, oh, I see what is happening. I gotcha.
I already had a
Yep.
generic reg cred in there.
Yep, I gotcha. I'm following you now. That's why it
You-
didn't work. Yep.
Well, I mean, even though I could dump it and get the value and everything was there and it looked all right, it just within didn't recognize it, I guess.
Oh, computers. Kudos, by the way, whoever left out loud and reminded us to widen everything up to 777. I am so resistant to that I wouldn't even have thought of that as an answer, honestly.
I figured a last resort.
Yeah,
Could
no,
be
no,
hard.
it's appropriate. This is not
You know,
production.
They'll blow this make away anyway. It's not a production system.
Just make sure you take that S out, Mita, because you've got a Docker instead of Docker.
What are you asking, Paul?
Yeah, sorry, Paul. What's the, clarify that for
Does
me?
the dash name have 2 spaces in front or no?
No, the dash is at the same level as the I for image.
Cool. Thank you.
Wait, okay. All right, there you go. Okay, so. Then you're gonna edit your YAML file. Oh, hold on. Wait, 1 second. Hold on, Mita. Can you get that secret that you just created? Because there is a space between dash and type, which I'm not sure exactly what it did with that. Yeah, take that space out between that dash. The last one, not the first one. There we go. Just take that dash out, just run it again, just to see what it wants to do. Because I don't know what it did with that. Because it should have thrown an error. And instead it just soldiered on, which threw me off. So press enter. You don't have to go to the end, by the way, to press enter. I would delete that and rerun that command.
Yeah, so that's what I had to do.
Yeah,
Kube control, delete secrets, reg cred.
that's it. Yeah, it's a much more simple command. So here, let me type it out.
Cool.
Good. That's great, Paul. There we go.
I wish we had a lab on YAML, and then every lab after that, just let us copy paste. 'Cause I
You
think
know
you do
what?
it once.
You know what? That's not a bad idea, actually. Hold on.
But
I'm
I think
writing
if-
that down.
Yeah,
The,
actually.
the,
Yeah.
the Katacoda stuff, if you click on the labs, you click on the YAML, it just dumps it into
Yeah.
and types it for you.
I think it's worthwhile to have the pain once, but not for every lab. I think we get it.
Have us set up VS Code with a linter so that it's saved every time you try to run something.
Well, yeah, the opportunities abound now because it definitely has been escalated. All right, there we go. Perfect. Good job, Mita. Okay, so then what you want to do is at the end of your empty dir file, which actually Paul was gracious enough to post in, is that you want to put that image pull secrets with the dash name : regcred reference. So I would edit your empty dir pod YAML. All right, so Mark. Well, hold on, we're almost there. If you tab that out, by the way, that should finish the rest of that for you. Okay, good. So your dash starts running underneath that I. There we go. Yep, perfect. Regcred. That looks good. Okay, so save that, and then you can exit out, and then kubectl apply -f, and then the empty dir YAML file.
So I'm going to apply this first, right?
Yes, you're going to apply it first, and it should unblock you. There we go.
That's okay. So I'm getting it's already exists.
Let's see.
No.
Type kubectl delete -f empty dir pod, and then just reapply it.
So I'm again, okay. So you want me to delete again?
So scroll up to where you get kubectl apply. So arrow up, sorry. Yep. Replace apply. Nope, go back down. Arrow down. Go over to apply and type in delete.
I already did all that.
Good.
Okay.
Good. Excellent. Now give it a second. Now scroll up twice. And then just hit enter again. That's it.
Not just created, got you.
Yep.
Okay. This took forever.
So type in kubectl get pod.
Get what?
Yep.
It's running now.
That's right.
Good.
Right. So you should be unblocked. So you should be unblocked. For
Yes.
any pod that you create, if you put that image pull secrets name regcred in there, it'll actually use your credentials to log into Docker and you won't have any issues. I do want to mention though, like again, just that like, I don't think it's going to be an issue unless you run into any resource limitations on the pod. But those scalar deployments, obviously it says out of CPU because it's showing you that you don't have any resources left. Just make sure that I don't think any of the other labs have any resource limits in them, but just something to be mindful of. Otherwise, you're good. You're good, Mita. You did good. You can now finish the rest of the lab.
You can now start the lab.
Well, she got pretty far actually.
Oh, okay.
All right. All right. So Brian, let's see. Still getting image back off. Let's see what you got. Oh, hold on. Wait, Mark was first. That's right. Apologize, Mark. That's right. You were the next person. Mark. All right. So show me what you got. Okay, so image pull secrets needs to come under containers, actually. But were you getting an error, by the way? I'm assuming you were.
Sorry, I need to unmute. Yeah, I was getting an error.
Yeah, so image pull secrets needs and the line underneath it need to be in line with containers. So just back them up 2 spaces. You don't have to delete them.
What did this say?
Regcred. REGCRED.
Is it back them up too?
Yeah, just backing up 2 spaces. Yeah, there we go.
So they don't have to be underneath the
Oh,
one that,
I'll show you what I'm getting. Oh, what the piss.
There you go.
All right,
All good?
grazie. Let me try to maximize my thing so I can unshare.
I gotcha.
All right, thank you.
Yeah. All right, Mark, so you should be set. All right, Brian. So let's see. Was the forbidden thing fixed or are you still getting?
Yeah, that got fixed
Okay.
by deleting, but there's still a problem with the image back off.
Okay. Did you create the secrets and all that?
Anybody got the YAML file without the page break in it? I know I've probably made a mistake somewhere.
I posted it in the chat.
Here, we'll post it just again, just to make sure. All right, so Brian, did you create the secret with all the and add in the image full secrets and all that? Okay.
Hey,
Did
I
you-
think me and Brian were having the same issue. I don't know if his audio's not working, but I think the way I fixed it, because it was in the same exact spot with the image pull off, was exactly what you guys showed on the screen a second ago with changing the or adding the image pull secrets and then the name regcred. I had to stop the pods and then restart the pods, and then they came up.
Stop the pods.
Or actually, not stop them. I deleted them.
What? And I think you just deleted empty dir, if I remember correctly. Is that correct?
Yes. Yeah, I deleted empty dir. I think I can look at the exact command, but it was like
Yeah.
kubectl delete empty dir pods or pod, and then just did apply again, and it came back up again, or it came up as running. Hope that helps.
Yeah, so
Perfect. Thank you, Jonah. Yep, that cured me.
Excellent.
Beers all around.
it still says image back off.
Okay. So when you created that secret, had you already run the Docker login command from before?
Let's see. Line 287. Right. Run it again.
Did that actually work?
I thought I got an affirmative on that one. Loading and succeeded.
Perfect. Good. How
Okay.
did, so good. You got Docker working. Okay, good. Now go back and delete that secret because that path is actually wrong if you use that particular method. And that's me because I was going after the root thing because we couldn't get it to work, but I forgot about the 777, the power of 777.
Okay, so delete the secret.
Yeah, delete the secret reg cred.
Okay, it's gone.
Good. Now rerun like number 302, for example, but the difference is that I want you to change the path.
But this says a pound sign in front of it. So, okay.
So change the path from /root to /home/wasadmin.
That's not I thought it was your VI.
That's all right. I'm used to having VI on the command line as well.
So that should work.
Home wasadmin. Yep, that should work.
Created.
Good. Okay, excellent. Now, do your empty dir YAML has the reference to the reg cred inside of it already?
We can verify that, but yes, I believe so.
Okay. Let's take a look. Yep, that looks great. Image pull secrets, name, reg cred, perfect. Okay, so if you've already applied that, then assuming that actually works, the only thing you might need to do is to delete the empty dir and just reapply it, see what happens.
Empty
Yep.
dir. So that one,
.yaml.
it says it doesn't exist.
You need to put .yaml on the end of that.
Oh.
Yeah.
Well, dot.
You can just tap it out if you want to.
Does not exist. So
Well, hold on. Can you ls the record?
YAML.
Yeah, I think it's YAML. Yeah.
did I spell it wrong? Yeah, they're all spelled YAML. Okay.
Hey, Brian, you have one of the most evil laughs I've ever heard. That was a good one. That was a good one.
Yeah. Yeah,
We are resuming
I'm watching too
lecture,
many movies.
Matthew, at I would say at this point probably 3 because people are still working on 9, unfortunately.
Okay,
Okay.
so it's getting rid of that.
Good.
And I should just recreate it.
Just reapply and see. It should unblock.
It's taking its time.
It is thinking.
And I should just change that delete to apply, right?
Yep, that's it. Okay, and if you get pods now, hopefully it's showing that they are running. Now remember, for the ones that have been sitting there for a while, the exponential back off gets longer and longer. So it might take them a couple minutes, if not longer, for them to actually recognize that you now have credentials. still happening. That's interesting.
Bunch of them.
You're saying the pods will take a while to spin up, or
What if I should delete the other ones? If that's holding things up.
It can actually hold things up.
So I would just say delete pod, yada, yada, yada.
Well, and if there's a deployment, if you delete the deployment, it deletes everything else. Sorry, I did say 3. Here we are resuming at 3. Matthew, I hope you heard me.
Okay, so it would be this one. Do I have to give explicit names? Oh, I don't have an Nginx. It'll create one. This YAML will create one.
We'll do a kubectl get deployments instead of a get pods.
I'm sorry.
Do a kubectl get deployments instead of a
Okay.
kubectl get pods. And that'll tell you what deployments you have.
That's spelled wrong. Deploy. Yep. Left hand doesn't know what right hand's doing. Okay. So there's an Nginx deployment, but there's no Nginx. Well,
Yeah. So what I would do is I would probably delete those deployments and it will actually get rid of all the pods for you.
all 4.
Yeah.
All 4 of these.
I mean, if you want to keep the Nginx one, I think that's fine, but the rest probably should go.
I think it'll just let you put a space in between.
Usually it's a comma with no space, but try it. It may work. Let's see what it does. Boom,
Oh,
done.
yeah. So it's Nginx.
And so your pods should have changed. It'll take a second, but it should have basically let go of the pods as well. Yeah, and then let go of label pod and empty dir pod and you're good to go. Well, maybe not empty dir pod, like get rid of label pod. But the other thing is that we could describe that empty dir pod and see what it says. Hopefully it's not still saying I'm stuck. Mark, let's see. Step 5. Pods don't seem to be starting up. It says, wait a minute. Ooh, that's an interesting error.
Yeah. Server doesn't have a resource type label.
Oh, sorry. You have to put a pod after describe. Put like pod. Sorry, the word pod. There you go.
Back off. Failed.
Okay, so it looks
Right.
like it's basically executing a back off. X40 over 92 minutes.
Translate that into English. I should delete it.
Yeah, I would delete it.
But that's
Well, I mean, that's the label pod. That should be gone anyway. We'll let that one go. Just out of curiosity, if you do a Docker pull Nginx, what does it do?
Looks like it did it.
Huh. Well, I mean, you are logged in at this point, so it should be working.
Right.
Okay.
So it should use this one that's local instead of going and trying to pull another one, right?
The image space for the Kubernetes for the kubelet is different, I think, than the space that your user is operating in. But anyway, at that point, I would say get rid of label pod, And then maybe just redo empty dir pod one more time. Because at this point, it looks like everything's authenticated. The only other issue is probably the thing we ran into with Trevor is that there's still something wrong with the secret. Because we know the YAML for the secret is good because when we added it as an image pull secret, it worked fine. But for some reason, it may be creating a malformed secret from the file, which is just something we may have to look at. But I would delete empty dir and label dir and just see what happens. All right, so Mark, when you describe empty dir pod, is it doing the same thing and saying that there's a back off?
All right, so what I'm at is in the PDF where it says open a shell into the pod kubectl exec it empty dir pod bash. It just basically says container not found. When I do a get pods, my pods, they're not ready, I guess. They're still 0/1.
Right. So exactly what we were just doing with Brian.
Yeah, I believe so.
Okay.
So I tried deleting them, but for some reason it gave me an error as well. So it's just kubectl delete pod and then the name of the pod, right?
Yeah.
Yes, but if it's part of a deployment with a replica set, you have to delete the deployment, right? Because the deployment's going to keep the pod up and running. So make sure you get your deployments and delete those for ones that you don't use, which basically at this point could be all of them. You can just delete all your deployments. That's
What was it now? The get kubectl get deployments.
Get deployments, yeah. So Paul, that error is actually for Kevin at least is not due to the pull rate limit, but it might be the same thing, Mark, that you're seeing because of the pullback. Yeah, Kevin, when you try to pull Nginx as the WAS admin, remember all that stuff that I was just doing with Mita, where I did a change mod like this command earlier, the 777.
Right.
Kevin, that's what you need to do is you need to do a change mod 777, sudo change mod 777 against the var run docker.sock.
Okay. Thanks.
The problem we're having is that the machines, for whatever reason, weren't set up for WAS admin to have access, which makes it a little bit more complicated to actually set up the secret. So this is the command that I would run. Let's see, there's a lot of noise on the line, so I'm gonna mute for a second. There we go.
Okay, this could be a problem with this as well. It's to do a schmod on this.
Oh. Yeah. That would be a problem because it's but wait, I just saw your Docker login work. That's weird. Anyway, go ahead and do that. That doesn't gonna hurt anything. So I didn't see an error though when you ran Docker login earlier.
No, there was no error.
Which it should have thrown an error if that was actually the problem.
But we can still see that this empty pod is not working.
So that means the secret's still not working. So that's still the issue. Okay. So then let's do this is that delete that empty dir pod, delete the secret, and then let's just recreate the secret. Or actually you can leave the empty dir pod, delete the secret, like 319, and then
Okay.
and then
recreate it.
run that whole login command again.
So 317.
Good.
Okay.
All right. And then this time, let's actually just do a quick cat on the, home dir for WAS admin, basically. So home directory /.docker /config.json.
A little slower, please.
Oh yeah, sorry. I'll type it in. So
Is it cat?
yeah, so just do a cat on this ampersand /.docker.
Ampersand?
Oh, sorry, tilde. I'm just making up punctuation over here. Tilde /.docker. It's a hidden directory, so .docker.
Oh, it's a hidden directory.
Yeah.
Name of the file is Docker config.
I thought it was config.json. Let's see what it says. Yep, that's right. Okay, so that's legit. It's there. The auth is there. So rerun the create secret command now.
322. So it's was admin, right?
Yeah, so that would be 321, yeah. Or 322, whichever.
Created.
Oh, hold on.
What?
This, I ran this with Mita and I wasn't sure. So see that dash type and that space in there?
Oh, it has.
I don't know why it's not throwing an error for that.
How did it end up with that? Maybe it's in the documentation that way.
Yeah, so I would
Error
delete it
from
again.
already
and recreate
exists. It said
Yeah.
created it.
I know, but the problem is I don't know what it did with that.
Well,
It didn't throw an error, which is what it should have done,
delete the
right?
secret
Yeah,
and run it again.
Okay,
Okay, so,
cool.
and
So
then,
then I would get pods at this point, see if that made a difference.
Yeah.
Still not working.
nope,
That is quite a mystery. So we have the credential.
mhm.
It's referring to the credential properly. We checked
We
it.
have the
There's no
login
spelling.
from,
Login worked. We checked the config.json. Everything's solid.
we did do the config JSON.
Mhm.
Can delete it and recreate it, I guess.
I think though that we did a good job of just verifying that it was there. Let's take a look at the secrets though. Let's see, why don't we describe the secret? Let's describe that reg cred secret for just a second, see what's going
And
on.
that's kube control, right? So,
Yeah. Kube, key, CTL.
I probably have it in here. Why type it in again? Describe this.
Yeah, 183 looks like it starts it.
194. It puts it into less.
All right, so there's the default token, there's reg cred, yeah, got it. Okay, yeah, there's a Docker config,
So this is
JSON.
kosher too. Anything that's amiss?
Mm-mm. That looks exactly like it is. Let me check on another thing here.
Still. 01. Nginx. What does it say? 31 hours ago.
Hey guys, if you guys get down to page 87, step 4, you're going to run into the same issue with that YAML. So you want to put in that image pull secrets and then name it reg cred, delete the pod, bring the pod back up, and then it works again.
Different.
Just to speak to this in general, because I think Trevor and I started to talk about this earlier. Maybe it was Trevor, it may have been someone else actually. Is that the other way that you get around this in production, by the way, is you create a service account that's associated with the image pull secrets. And then what happens is that everything you launch uses that service account. And then what happens is that image pull secrets is automatically appended to any pod spec that you dump into the system. So I think that's the path that we were referring
It's
to.
an
earlier.
easier way of doing it. Yeah, I like that. Nice.
Yeah, and so it does it for every system. But adding an SA account actually has its own headaches. So Yeah, but that's probably how we're gonna solve this in the long term. Okay, I am a little bit at a loss, honestly, about why this isn't working. Can you do kubectl edit on the secret? So it's just kubectl edit and then secrets and then red shred.
And it's no slash or anything.
Mm-mm. I mean, you can put a slash there if you want to, but it's red shred.
I mean, I don't know if it needs,
It takes both syntaxes where you do a like pod slash or secret slash and then the object. It takes both syntaxes.
and it's REG
CRED,
C.
RED.
I can't hear your last couple characters.
It's REG CRED.
CRED.
You could possibly make this go faster if you go up to view options at the top of the Zoom window and select request remote control.
Oh, yeah. Although, it's kind of I know it's weird, but it's kind of a good learning experience for everyone.
Rather than having to dictate everything to it.
That's base 64 encoded. Let me copy that really quick.
It's
It's the
today.
right value. Okay. That 64-bit encoding actually is accurate. Okay. Decoding reverses that out to the right thing. Okay. Strange. Now I'm really weirded out. That is the right thing. When I base 64 encode that path from earlier, that's what it yields. So,
Monster.
huh. Yeah, I don't have a good answer for that one. Frustrating. Okay, well, given the time left, I don't think we're going to figure it out, unfortunately, with the 3 minutes we have left.
So we plunk another one into the not completed column.
Yeah.
Well, if you can't get past the elementary steps of it, I mean, everything else is predicated on that.
Yeah.
It's a no-go.
Yeah. All right. Well, we'll back off of this just given that we have the time left. Hopefully
That's what
that
the
will
system
become
says.
less of the issues when since it'll be a week for people to kind of
Look,
like
it
poke at
finished.
this.
It finished. 1-1.
Okay. Did it just need time? Is that what it needed?
I don't know, but it had all the components. So let's see.
Okay.
Hmm.
Okay. Good deal. Kevin, did you add in the secrets and do all the stuff that we were doing for the last little bit?
Not yet.
Okay. All right, so it's 3 o'clock. Again, just because we did another kind of intense and I think semi-frustrating lab, let's just take a 10-minute break this time. So come back at 10 after. What we're gonna do is we're gonna jump into Helm, and then we're going to do the CI/CD section. So, and those will be our last sections of the day. The next lab that we do on Helm is actually gonna be a relatively short lab, actually up in Katakoda, because I'm just going to assume that there's going to be disastrous for the time being until the rate limit backs off on Docker, right? And everyone having to go through that, I think, would not be useful. So that's a 10 or 15-minute lab, right? And so we'll just do that as we get back. So it's 3:01 right now. Come back at 3:11, and then we'll resume with a focus on Helm. That really awesome show. Let's dive into Helm a little bit. So Helm is the de facto kind of package manager for Kubernetes. It is run by the CNCF. Just to say this, just because Helm is run by the CNCF does not make it the most ubiquitous way in which people deploy to Kubernetes. Because frankly, Helm is maddening. And I'm going to just tell you why as we get into it. But Helm is not as awesome as it should be, especially after 4 or 5 years of running. But Helm is considered still it's kind of like Jenkins, right? Jenkins is a little long in the tooth. It's been around for a while. It's got a lot of plugins. It's a good CI/CD server. But GitLab or any of the other tools like Circle CI, Travis CI are way more modern and way better. Helm doesn't suffer from that problem. Helm's problem is that it's inconsistent. It's hard to find consistently good software on Helm. But if you want to write your own Helm charts and you need a structure to do so, Helm is absolutely fabulous for that. So let's talk about that. So Helm is a package manager for Kubernetes. It literally is Helm install and then go to town if you have the right repository. So for example, if you want to Helm install Redis and you've got a repository for Redis inside Helm, it's good to go, right? So literally with like a single command line, you can install like a whole orchestrated system just with a few like command line executions. So it basically allows you to use the Helm command to install these complex pieces of software. Now, hub.helm.sh is like the service for storing and retrieving Helm charts. Helm charts are basically just definitions, right? Right. So if you're out here and you're like, hey, I'm looking for a Helm chart for Redis as an example, right? There it is. And so what that does is it allows you to basically add the chart to your system. And so here, by the way, it's actually literally showing you the URL that would allow you to pull in the chart in question. So just so you know, Helm uses this concept kind of like the way any of the repo systems do, is that there's chart repositories that you add into your Helm installation, and they make available certain packages of software. So Helm can be installed a number of different ways. It's written in Go. I'm not even going to go over that. Helm, by the way, will actually use your kube config. So in your home directory, there's a .kube directory, .kube, and inside of it is going to be, like if it's Minikube, right? You're going to have like a .minikube directory. I'm sorry, you're going to have a config directory in there, and it's going to actually point to various items. So let's go take a look at that.
Quick question. Sorry if you mentioned it, but is Helm developed by the same people as Kubernetes or completely
I mean,
separate?
it's owned by the CNCF. So it's done by a different team, but it's owned by the same consortium, right? So in this, by the way, .kube directory, and by the way, I'm on Windows for this one. And you see it's the same, it's a .kube directory underneath my Windows home directory. Underneath here, by the way, is a variety of items, but the config item, oh, sorry, that's right. The config item basically shows you everything you need to know to get into my Minikube installation if you had access to my keys, which you don't, right? Now remember that Kubernetes doesn't have the concept of users. It doesn't have a user store. It identifies users through certificates. The subject line of the certificate will have the username, right? So looking at this, you can actually see down below at the very bottom, you can see the users is defined as Minikube, and then these are the client certificates that are associated with Minikube. Now, the reason those certificates are accepted is because up top where it says cluster and certificate authority, those certificates are registered with that certificate authority. That's how we define users in Kubernetes, is that you create certificates for them, basically. So the main point of all this is that in your home directory, when you actually set up any kind of Kubernetes cluster, there's going to be a .kube directory. And under that .kube directory, there's going to be a config file, and that's going to contain all of your authentication information for Kubernetes. The reason this is relevant is because Helm's going to use that information. So if it's not there or it's not working because kubectl isn't working for you, it's not, Helm's not going to work either. Now Helm allows you to bundle, publish, share, update, roll back, delete. You can create your own versions of applications. So Helm is the, like name of the project. Helm is lowercase is the CLI. And what happens is that you actually download and install charts with Helm, and charts are just orchestrated app installation. That's all it is. These charts are pulled from a repository. Hub.helm.sh is a repository. Bitnami has a repository of Helm charts. How do you find these? You just go out there and look, right? A reminder that you want to pull from authoritative sources when possible. And so in this particular case, Helm repo add stable. And then you're adding basically the Google API, the Kubernetes charts for Google API. So Google, by the way, hosts this particular Kubernetes charts, right? You can then search a repository by running Helm search, right? Which, by the way, you can run these commands if you want in our lab today, if you actually want to test them out. So even though we're going to be in the Kata Coda labs, you can actually run the search commands to see them work. And when you have a version of the chart versus a version of the app, you can roll things forward in versions. You can roll them back in versions, just like you can in Kubernetes. So notice that they use the name of the chart to install it. When they searched, they found Nginx. This, by the way, was a made up arbitrary name that they threw into the command to label their installation of this Nginx app. You could have called that, spicy blueberry conehead. Is that what my son called me the other day? Anyway, I don't know what he was smoking, but Helm install, he got it from Avatar: The Last Airbender. Helm install, and then the name, and then whatever the name of the chart is, right? This is important because it is going to ask you, by the way, like the specific name of the chart. And again, just notice that it got this from just doing a search against the repo. Adding repositories is as simple as just a Helm repo add, listing them, updating, and then removing them, right? By the way, all of this can be done in your Kata Coda lab that you're going to be doing here in a bit. So if you're out here starting your scenario, right? Oh, actually, you know what? Let's do this first. All right, cool. Right, Helm repo list your stuff. You can delete it. Other pieces there, right? So when we get into the Kata Coda lab, you can actually run all these commands that you want to. Just check them out. Charts can be found at this particular hub.helm.sh. So this is no different than hub.docker.com. So you've got plenty of options here. Now, in the chart page, just note this, that they always include like, hey, this is how you install it. So if we go back and look, right, this gave us the CLI that we would run if we wanted to actually upgrade this. Let's actually just stick this in Katacoda and see what it does for a second. This could be an utter disaster, especially if you don't add an H on. Oh, Falco has no deployed releases. Interesting. What does that mean exactly? Oh, that's probably for an upgrade. Let's see. Oh, Falco rules for sharing Redis. That's not actually Redis itself. That's just Falco rules. Hold on 1 second. That was wrong. I was just pulling Falco. That's weird. Let's try this instead. Let's add the Bitnami repo, right? So we're going to add a Bitnami repo into our little Helm repository. So that added the Bitnami repo. And we're going to go back and we're going to actually install Bitnami Redis. Be interesting to see if this works. This could be a disaster. Did I not give it a chart name? That does not look right. Oh, that might be why. Let's try that again. Maybe there is something wrong with this. That should be working, actually. I'm gonna write that off for a second. Regardless, I was just gonna show you that literally it actually puts the commands that typically you can run to get it working. But that's exactly what I was complaining about at the beginning, isn't it? Where I was like, sometimes there's these weird inconsistencies. I have no idea why that's not working. We're gonna figure that out here in a second. All right. So anyway, hub.helm.sh is where you grab the charts. Usually, by the way, what you do is you install a arbitrary release name, then you put the chart repo, and then you put the chart name. So if we go back to what I was just looking at, there's no reason actually that shouldn't be working. There's Helm install, there's my Redis, there's Bitnami, there's Redis. So what exactly is the challenge?
Hey, while you're doing that, can you break this down Barney style for me? What is Helm charts and how does it work? Sorry.
Charts are just orchestrated installs of software for Kubernetes.
Okay.
It's no different than apt or yum, right?
Oh, okay. Gotcha.
Yeah, this is
Okay.
apt or yum for Kubernetes. That's all it is.
You said that it's an orchestrated install, as if that was simplified.
It is simplified.
Oh,
Right,
I like his
instead-
answer of yum, apt, chocolatey. It's a
Yeah.
package manager.
It's package manager.
Okay.
That's all it is, right? Yeah. Sorry. That's all it is, right? Literally, we could just stay on this first page, right? That's all it is that it is literally a package manager for Kubernetes. That's all it is. Which, again, my complaint about it is that it's inconsistent, right? Apt and yum and chocolatey, which I love chocolatey on Windows. Holy cow, that's such a game changer. They're all really consistent, actually, as long as you can figure out the names and stuff, right? But Helm drives me up the wall because it's exactly the problem you're just seeing. Why is that not working, right? Now, that could be an environment problem. I'm not going to knock it, but more often than not, there's something wrong with the chart or the repository. So I find people using Helm a little bit less and less nowadays, but it's still useful to create your own Helm charts for your own custom software. I find people using Helm less to actually download open source software. Now, assuming that all this would run, for example, here we added the same chart. That's interesting. I wonder if that would actually work. Let's try that for a second.
Add the version on the end of it, just out of cute grins here.
Yeah, it's still asking for a chart name, which is a little weird because this is the chart name.
What version of Helm?
That's a good question. Maybe it's an older version. Oops.
Yeah, why is it everything Go doesn't do the dash?
That's a good question, because obviously I get confused. Oh, that's version 2. That could be a
That's
problem.
older.
That's older. Maybe that's the issue. Maybe we won't be doing a Helm lab today if that's the older version. Anyway, moving on. So here it is, Helm install. I guess that's the reason it works. I haven't touched 2 in like in a long time, but maybe the 2 syntax is different. But usually what happens is you install the software, it just installs it, and you can actually Helm list all, like install list. You can actually list everything that you've installed, and it set the whole thing up. And then what it does is it outputs what should be working inside the system. So maybe we'll end up actually trying to do this one actually on the labs. We'll see. So here is another thing where they're actually installing a release, and it's the older release. And then what they did here is they actually run a Helm upgrade, and they upgraded the release to the latest version. So just be aware though that the problem is that the chart version doesn't match the app version, right? So as you can see there, as far as outputs, 5.0 matches like 1.16, right? Whereas 6.0 matches to 1.19 of the app version. So just know that they name the versions of the chart whatever they want. I don't know why they do that. I wish they would just keep it consistent with like everything else, but it isn't always the case.
Do they have to do some sort of configuration to get a chart working for a specific app version?
Typically all they need to do is just upgrade the core app. Once they've set it up, all they have to do is upgrade the core app, and that's it, and change a couple of numbers.
Okay.
Yeah.
It's the only.
Yeah, so I'm not sure exactly why keeping it up to date is such a big deal, right? So. Just to mention this is that this is a wrapper around the same YAML files that wrap around the same container definitions and everything else that we've been running. So just so you know, this is just a wrapper around YAML file creation. That's all it is. So in the lab, you actually have the ability to download a Helm chart and edit it and kind of like customize it yourself. So particularly if, and actually I think Trevor, I see that you have this responsibility, is that if you need to create your own custom Helm charts, the lab that we have for this actually in the system is absolutely spectacular for pulling those charts down and seeing how that functions. Because creating a Helm chart is a pretty minor thing depending on the sophistication of your app. So just to stick with this thread, we'll get to that in just a second, is that once you install a particular version, you can then easily upgrade it to the next version and then just list your installations. And then you can actually just roll it back one if you needed to go back, or roll it back 2 or 3 or whatever you needed to. So once you have a history with Helm actually managing your installations, you can roll them forward and back as you need to. Now, creating custom charts is just a matter of doing Helm create, and then you can just execute a name. So in this case, my app, right? And so, really? That's not fun. Let's see if I have Helm installed here. I do. Let's see. Let's get out of that directory. So underneath my app, yeah. What I did here is if I do a Helm create and I do my app too, what happens is that underneath here, I've actually created let me clear this out. What I've done is I've actually created a template, if you will, for creating my own Helm chart. So think of this as a way of you creating your own software packaging that can be used by you by Helm, right? So notice that in this whole thing, if we take a look at it, oh God. That's right, because my virtual machine's not working. This has just been kind of that week, actually. So if I were actually to get tree to function, this is actually what this would look like, right? Charts, chart.yaml, templates. What would happen is that, as you can see, you see charts, charts.yaml, you see templates, and you see values. If we go back to what I was just looking at, you can see I have chart, chart.yaml, templates, and then values. If we take a look at values just as a thing, it basically, you can come in and define things like resources, ingress controllers, run as, which is what we were just looking at for security context. I can basically parameterize everything for the app that I'm about to launch via Helm. Pod security group context, if there's a service account, I can specify that, right? I can set my replica count. These are all default values that you can control. And once you put them in here and you put your application in here, it will create your pod YAMLs and submit them to Kubernetes exactly as you have them listed here. So this is really powerful for you creating your own custom charts that you can use for your own internal software. Now, there's other stuff in here, like if you need to define or create service accounts, there's a service account.yaml. There's ingress. Here's the deployment. If you have a stateful set, you'd rather do that, you can do that instead. You can add a stateful set.yaml and just add that into templates, right? So this allows you to create all of the objects necessary for you to deploy something. Now, just to say this, the chart.yaml that we saw, all it has in it, by the way, is the versioning. That's it. That's all it really has in it. But the values.yaml actually has real values in it. If we go look, for example, under template, and we, let's say, cat deployment, notice that there's a bunch of substitution code in here. So you're probably looking at this and going, Michael, that looks really complicated, right? I mean, some of it is pretty obvious, like as far as like, here's some readiness probes and some live probes, here's the pull policy. But then notice that for a name, it's actually substituting the chart name. If we look at, for example, image pull secrets, then it's actually gonna like look at some of the YAML to find out where the image pull secrets are, right? So there's a bunch of substitutions, including indexes in here as well. So notice that all of this is going to pull from that values.yaml file that we were just looking at. So if we go back up and cat the values again, this is where it's getting all that information. So when you want to create your own custom Helm charts, you pull down this template, you start replacing the values with the information that you want, such as how many replicas, what images am I using? Do I have a service account? What's the service account name? Like all those objects that you want to create. And what will happen is that you're basically just creating a bunch of YAML for the deployment of your entire product. That's all you're doing. Just that simple. Yeah, Trevor, the reason tree's not installed is because it's git bash, which, you know, I usually run inside of a virtual machine, but VirtualBox broke for some reason. So
No, it wasn't installed on the VM.
oh, it's not on the VM. Oh, that's weird. That really takes me aback, actually. So this, by the way, Helm Create just allows you to start templatizing. Now, the rest of these I think we went through, but like if you need to create an ingress controller, this is here. If you want a horizontal pod autoscaler, this is what HPA is. Deployments, you know. The rest of these are actually fairly intuitive. Its values and chart are the ones that like you wouldn't know right off the bat. The rest of these are all Kubernetes objects, right? These are all Kubernetes objects. If you don't remember what HPA stands for, by the way, just look over here. Horizontal pod autoscaler. We only talked about that in passing because that's a more advanced topic, but it allows you to autoscale pods based on performance metrics. Just like you can use the cluster autoscaler to scale the nodes based on performance metrics.
So if we were doing this in a CI/CD pipeline, we had an application, we could then have that update the chart.yaml, increment the version.
Yep, that's exactly how it will be done.
Version is the chart version where app version is, you know, whatever the underlying application is, right?
That's what it's supposed to be. So that's the way at least I do it. Not all the charts do that. Like the Nginx one just now was actually accurate, but before, by the way, the Nginx numbering did not match the actual version of Nginx, which is maddening because you couldn't figure out from the chart what version of Nginx you were getting.
Because the app version in there wasn't the same as
the actual app version.
Ah, okay.
Yeah, they fixed that actually like about 6 months ago. So I think we talked about the substitutions already. So it actually is including values, right? And indenting them, obviously, because that's what YAML requires. Including the full name of the Nginx app, including the labels from the app, So there's a lot of substitution in these files, these template files that we're suggesting. So once you create a custom chart, you can actually just install it. You do have to give it a custom label, right? To make that work. And then from there, you know, that name is arbitrary. You can call it MS app or whatever thing you want it to, right? But once you've created it, you just refer to it in that local directory. And as long as it's right there, it'll just pull it in and go to town. You don't have to push it to a repository if it's a directory right there that you're at. Charts can also be packaged, which is what the Helm package command is for. What this does is it actually creates a TGZ file, a tar.gzip file that you can then use and actually push if you have access to push packages to the repository. You can also host your own Helm repositories. I think that Artifactory was either going to add it or already added Helm repository capability. So it's there if needed. So the idea here is that Helm is like apt or yum for Kubernetes. But because apt and yum are what, 20 years old, they are very mature and very stable, right? Also very complex. Helm is no different. The only difference is it's immature, right? So it's not yet there with the consistency. The main place you go to find good charts is hub.helm.sh. So that's the main place you go to look. But not everything's out here. Like I think Oracle has resisted. Like other people have put Oracle in here, but like Oracle has resisted it. Kafka, I think, is still out here. Bitnami is a company that goes to great lengths to convert software to make it available for the open source community. They're a great company, by the way. So Bitnami and Bonsai Cloud are two good ones. You know, one of the things I would mention is that make sure you, just like with Docker, that you stick with official verified publishers, right? So that's the other thing about Oracle, I think, that was kind of off-putting. There was nothing here. Yeah. So again, this is in its infancy from my standpoint. So just be very careful with this. You want to write your own charts? Awesome. You want to pull other people's charts? Be a lot more careful than you are when you pull Docker containers. Make sure you pull the chart down and read it. Okay. So this is logging, monitoring, and troubleshooting. Just looking at especially after we were just trying to like get that whole thing functioning, is that unfortunately this Kata Coda lab isn't going to work. And even after we took an hour lunch before, I'm almost guaranteed that the labs aren't going to function. So what we're going to do is we're just going to keep on forging ahead because the labs are just going to be a constant source of frustration at this point in time. And so we're just going to finish out logging, monitoring, and CI/CD. And then what we'll do is we'll pivot over to the labs, and then we'll just keep going until we run out of time right at that point. So that way I can set you up for success as much as possible. I guarantee you, if you run the labs tomorrow, you're not going to see the image pull off as much, right? You might, or at all in some cases. So, okay. One thing I do want to mention before I pivot over to this is that in the lab guide for getting started with Helm, it is worth mentioning that this does actually walk you through like how to basically add charts, how to basically untar or pull a chart down and expand it so you can see what's inside of it. So especially like Trevor, you're talking about writing your own charts. If you want to like model somebody else's, this shows you how to pull them down so you can untar them on your system and take a look at them, which is actually pretty useful. Especially if you find a good chart that you admire, right? And so you can actually see like how all this works. And then you can actually modify the chart for your own uses and then basically install it so you can actually see the output. And then I don't think there's anything else to say there. All right, so here, by the way, in part 5, you're actually modifying the chart. So you're pulling that chart down, opening it, expanding it onto the file system. You're editing it, you're modifying it, and then you're updating it and reinstalling it. So if you have to create Helm charts, this is actually a really good lab to kick the tires on. Just want to make sure that was clear. That's it. So I would strongly encourage you, once we get it like maybe like 12 hours or 24 hours away from like the blocking that we're having now, is to run that Helm lab, because you're gonna have access to those systems for a week. Because it is going to teach you a lot about charts if you ever have to go down that path.
Hey, Mike,
Yes.
do you mind if we do like a 2-minute break before the next one?
No,
I
not at all.
just, I got to do some jumping jacks.
Okay. Yeah. All right, let's do this. Let's take the next 10 minutes. So let's come back at 5 till 4. And then we'll just run through the rest of the last 2 chapters, and we'll be good.
All right, thank you.
Yep. Okay.
Okay, okay. Why don't crabs give to charity? Because they're shellfish. Ha ha ha.
I'll see your crab one. How about what website did Chewbacca get arrested for creating?
Trevor, you know me. No one watches Star Wars.
WikiLeaks.
That's a good one.
That was exactly why I went looking for one.
Yeah, man. Nothing like a dad joke.
Let's go hit John.
Yeah. John's gonna be next. I gotta find some Yoda dad jokes for him and completely botch them because I know it'll make him mad.
Okay. Welcome back. Let's talk about, not that. We're done with you. Let's talk about logging inside Kubernetes really quick. Let me share my screen though, instead of sharing the Bravo. All right. So we'll cover these last two sections and then we'll have a short chat and then you'll get unfettered access to the stuff. I'll make sure you have my email and stuff in case like something comes up. Oh wow, the jokes in chat. It got serious there for a second. Wow, I got distracted. All right, so here's the deal with logging, monitoring, debugging, and upgrading. So I'm just gonna tell you right now, I'm literally gonna completely skip the section on upgrading because it's far more comprehensive than that, and you're gonna need to it's gonna have to take it up a notch. So, but we're gonna talk about debugging, monitoring, and logging. The reason is the upgrading thing isn't useful because it just says, hey, upgrade this, upgrade this, upgrade this. It actually doesn't walk you through the steps. And the Kubernetes documentation on actually upgrading is very detailed. So just want to make sure that's clear. All right, we're not going to talk about the difference between logging and monitoring. Let's talk about logging. Logging in general is the act of capturing anything that is emitted by an application. And that could be an operating system application, that could be a database application, it could be Java, it doesn't matter, right? So the great thing about logging is that good logging usually captures significant state changes. I failed. I've started. I'm unable to reach the database. I just dumped a bunch of data in the database, right? That's what good logging does, is good logging communicates state changes, right? I just finished this session with this user. I just finished this session with this user, right? That's what good logging actually does, is it tells you, it communicates significant state changes that you care about. Now, sometimes you care about a lot of detail. Sometimes you care about very little detail. That's why logging usually has some variability to it that you can turn up if you need more information and turn down when you don't, right? Now, by default, when you have an application in a container that emits some information to the terminal, Docker will capture that. And because Docker will capture that, Kubernetes will also capture that. And it will actually hold on to it as long as that pod exists with that container. So you can see the problem is that if that pod crashes or moves, typically the logs go away because they're localized on the hosts that it's sitting on. Because there's no persistent storage for logs for Kubernetes. So then how do you solve that? Because just like your storage system, Your logs should be their own independent system. They need to be pulled off of Kubernetes and they should live somewhere else, quite frankly. So Kubernetes does not solve the logging problem. It solves a capture problem of capturing logs out of containers and writing them to the host disk. But something needs to get it off of the host into a central repository. Logs in Kubernetes by default are typically ephemeral, meaning they're not going to last very long. Maybe a day, maybe a week if you're lucky. So if you want to see the logs that Kubernetes can see, you just do Kubernetes logs and basically list the pod name and it will show you what's going on. It's just that simple. If you want to see a previous iteration of that container or pod on that same host, you just put -previous. If it doesn't work when you do -previous, it's because it moved to another machine and it doesn't have the previous logs. That is very fraught with variability. The solution is typically to put a logging agent onto the Kubernetes cluster. Now, out of the 5 workload types, cron jobs, batch jobs, deployment, stateful sets, and daemon sets, which of those are typically purpose built for putting on every node in the cluster? Daemon. Yeah. Daemon sets are purpose built, like FluentD, for example. If you put that on a node, it's going to gather all of the Kubernetes logs and then send them off to Elasticsearch or where their data store you specify, right? So you can see here that every pod, bullet number 4, every pod in the K8s cluster is going to try and write to var log containers, right? And so what will happen is FluentD has a logging agent, will capture that, pull it out, and then send it off somewhere else. This is standard. This is a standard practice. This isn't just a Kubernetes thing. This is true for anything. To pull the logs off the system and put them onto a centralizer of some type. Splunk, Loggly, Logzio, there's others, right? But there's third-party services that do this in addition to Elasticsearch. Now the Elastic Stack, of which Elasticsearch is one part, along with FluentD, is literally what I was just talking about. As you can see here, we've got nodes, but what they're doing here is that every node is running FluentD. So the nodes themselves are writing to port 9200 on Elasticsearch, and they're using Kibana to visualize the logs. All standard practice at this point. So just so you know, that's the standard way that's solved. Elastic is probably the most common method other than a third-party provider. So Elasticsearch, Kibana, Logstash, FluentD, FluentBit, those are the 5 technologies that are most commonly used to solve the logging problem. So what you need to know right now is that logging is not solved by default by Kubernetes. And if you can't see the logs, it's because they're not running through Kubernetes. They're being exported somewhere else. By the way, you can use syslog and other facilities, so don't feel like just because I said that's how most people are doing it that you can't use any other technologies. You can. Syslog, by the way, especially if you're using an rsyslog or one of the more modern variants, works great for some of that stuff.
Can you name off those 5 again?
Yeah, absolutely. So the Elastic Stack consists of Elasticsearch, data store, Kibana, which is actually listed there on the right-hand side. That's a visualizer, so it's a dashboard. And then Logstash is their product, which by the way includes things like Beats. They have this thing called Beats, which is like a slimmer version of Logstash that are purpose built. So there's actually 4 components there that belong to the Elastic. So Elastic is its own company. You should probably know them because they're frequently in fights with Amazon, which they frequently lose. But good for them for punching a bigger guy in the mouth, honestly. And then the other one is FluentD and FluentBit. FluentD is an older product whose job it is to gather logs from nodes. FluentBit is the CNCF project, and its job is to gather application logs directly from the applications. So let me repeat that. FluentBit and FluentD are cousins of each other. And then we've got 4 from the Elastic side. So there's Elasticsearch, Kibana, Logstash, and then Beats, of which there's like 20 Beats that I know of. There's Windows Beats. There's like audit Beats. There's like all kinds of Beats. I know.
Okay. Thank you.
Now, in the space of monitoring, which is different. So if logging is trying to capture significant state changes of an application, monitoring is basically to check in general, it's to gather metrics about what's going on in an environment. So whereas logging could capture just state changes, monitoring is mainly measuring not just state changes, but metrics. Is this on or is this off? Is latency 100 milliseconds or 200 milliseconds, right? Is this system under disk pressure? And if so, what's the percentage? Is it 87% disk pressure? Are there 50 things in the disk queue? Is CPU utilization at 100%? Logs can gather some of that, but typically they don't. Monitoring is more interested in the numbers and the metrics. Obviously, there's crossover. If there's a Venn diagram, there's crossover, right? Now, Prometheus is purpose-built to integrate with Kubernetes. So don't get me wrong, there's Isinga, Sensu, Nagios. I could name off a bunch of monitoring systems, right? Even CloudWatch up in AWS, right? But Prometheus is an open source tool that is designed to scrape metrics from Kubernetes and other things, anything that's API driven, to be frank. And what it does is it makes these really ugly dashboards. Isn't that pretty? You feel inspired? Just so you know, Prometheus is most often paired with another product called Grafana. If you haven't used Grafana, by the way, it's very pretty. And for some reason, for a while there, I was compelled to spell that with a PH, and I have no idea why. I'll take a look at that. Oh no, why'd you do that? Hold on. Let's grab another one. Look at that dashboard. Isn't that pretty? That's the thing, by the way, you put in front of your CTO and your CPOs when they want to know what's going on. Because I don't know if you've heard this before, but you should definitely be feeding your leaders some kind of like chew toy dashboard that they can use. I'm not denigrating them. I'm just saying, right? You don't want to give your leaders the same dashboard that you give your fellow sysadmins, right? Give your leaders a chew toy that shows everything is green until something's not, and then it turns red or yellow, right? But don't give them the details. They don't need that, right? They got enough details. So Prometheus and Grafana, kind of like microservices and containers, they go together like peanut butter and chocolate. Typically, Prometheus is the scraper that gets all the metrics from all the systems, and Grafana is the one who makes it pretty. Now, could you use Kibana for that? Sure, you could use Kibana for that. Kibana is owned by Elastic. That was the thing we were just talking about. But just to say this, Grafana is purpose-built for metrics presentation. Kibana is purpose-built for log presentation. There's crossover, but Kibana is meant for log presentation. Grafana is for metrics presentation. So pretty customizable. You can put great colors in here. There's lots of options for graphs and stuff like that. So Grafana is really like the way to go as far as like metrics. So great options. By the way, this product is so popular that Amazon, which has had its own flagship metrics and dashboard tool for 15 years, just launched a managed product of Grafana and Prometheus as part of their service offerings, which I think is one of the most interesting plays they've done for a while. This product is so good that Amazon actually is competing against themselves over it because they know people are going to adopt this. That is the weirdest thing in the world. They are such a funky company somewhere. Okay. Now, what kind of things can Prometheus gather? Prometheus can scrape anything that has an API. Bottom line. If it has an API and has numbers in it, Prometheus can scrape it, right? So just know, like you can see it right there, right? Memory usage bytes, disk pressure, like if it can see it in an API, Prometheus is going to scrape it, which means it's going to ingest the data and the numbers that it represents. You can also add alerts, which again, that should be expected, right? Some of the alerts, by the way, can be predictive, like, hey, this is normally this way, and now it looks like this. And then some of the alerts are binary. Hey, we just crossed 90% CPU utilization. So some of the alerts are like, you know, what they call like, you know, they're trying to anticipate failure. Like, hey, there's a deviation here, and some of them are just straight up like binary, right? So that's Prometheus and Grafana. So those are the main tools that are used. You can actually, just to be frank, Datadog, App Dynamics, New Relic, there's all these third parties out there. And there are tons of open source projects that have been around for 10 or 15 years that will also interface with Kubernetes. So I'm just mentioning Prometheus because it's probably arguably the best one. And quite frankly, if you use it now, it's probably the one that everyone's going to use for everything else if they can, because it's been rewritten from the ground up. But just know that your older tools will absolutely work just fine. If you're using Isinga, Sensu, Nagios, Xenos, whatever, Spicework, they'll all work just fine. As long as they can scrape an API, they'll work fine. Now, we've actually done this section already. You know why? Because we've had horrendous problems with the labs. So you guys already know a little bit about debugging, right? You already know that you want to like get information. You might even cast it wide with YAML. You might even describe, for example, pods or deployments or whatnot. So you've had a lot of good like troubleshooting experience already. We didn't get events. We didn't necessarily look at logs, although we could, although we didn't need to, because most of our problems were Kubernetes problems, not application problems, just FYI. But that's the traditional way, is that typically you're trying to get as much information. So get pods, describe pods, get events on the system, right? Do a -o YAML or a -o wide to get more information, because that's always the game, right? The more information you have, the easier it is to troubleshoot. To be upfront about this, the problem that most of us have is that we're not reading the information that is in front of us, right? If it says something along the lines of like, hey, right, you are unable to actually talk to like this particular file, you're not going to start troubleshooting a network problem, right? It's telling you it's having a problem with the file that's local on the system, right? And so that's the main challenge most of us have with troubleshooting, is that we don't read the error and we draw the wrong conclusion, right? And so that's the #1 problem with most of the Kubernetes troubleshooting I see, is that either I don't have enough information, which is not always the case, or two, I am misinterpreting the information that I'm seeing. So just know, as you run describe on pods and as you get like more information on pods, make sure you're really looking at the event information, because it will typically tell you what's wrong, right? Or like it'll tell you the object that it's having issues with. Here, by the way, that was all debugging pods. Debugging nodes does the same thing. Just describe the node, get node. There's only so much information that you need, like that you can see. And when in doubt, when troubleshooting, start methodically changing things. And I say methodically, what I mean is write it down. Especially if it's 3 o'clock in the morning. If you are not recording what you're doing or writing down what you're doing, or preferably both, when you're troubleshooting, especially at 2 or 3 o'clock in the morning, you are setting yourself up to fail, like doubly. I can't tell you how many times I've been in environments I come in, and it's like, hey, why, we've been down for 2 hours. Hey, what's going on? How can I help? And they're like, well, we made 15 changes, but we only remember, 2 of them. Awesome. Good. So now we'll never find out unless we go back through history and start doing file comparisons about what actually changed. And luckily with Bash in particular, there's a good history, but like, that can get really complicated. So just know that also when you're debugging, you want to be as methodical as possible. And if you're in doubt, just record what you're doing. Just record your screen. Tee it out, record it to a log file, record your screen, just show everybody what you're doing, right? The other thing is that when it's 2 o'clock in the morning and you're troubleshooting a complex problem, get a second person. That second person will stop you from doing something really dumb. I almost deleted an entire, hypervisor. I almost deleted the whole thing because I thought I was somewhere else that I wasn't, right? That was just like a couple years ago. So, get a second set of eyes. When I set up operations teams, people always work in triplets. 2 people are watching, 1 person is recording everything that's happening, right? Even if they're asleep, like half asleep, right? They're still recording everything. That way you got somebody recording what's happening and they're thinking strategically, and you got 2 people watching 1 person type, and they're making sure that no mistakes are happening. Quality goes through the roof, problem resolution gets faster. So, and besides, just as human beings, we're really not designed to operate alone. So, okay. By the way, these debugging commands are just going to repeat themselves again and again and again. Get and describe. Git and describe. Those are really your two friends whenever you need to troubleshoot. Okay. Last thing, I promised I wouldn't talk about this, and I'm not. Upgrading Kubernetes, you should read the Kubernetes documentation. By the way, if you're on a managed service provider and you go to upgrade Kubernetes, you know what is involved in that? Click. Come back 3 hours later, everything's upgraded, nothing has gone down. And if you do this, by the way, manually, these are the steps. One node at a time, you have to upgrade kubadmin, get an upgrade plan, apply the upgrade the core software, and then restart the node basically. And you do that for every leader, and you do that for every single node in the cluster, one node at a time. So this is where your Ansible, Chef, and Puppet are your friends, because they can do this for you one node at a time so that you don't have to sit there and do it manually, right? So, but this is something you want to orchestrate. That 4,000 node cluster, there's no way we would have actually ever been able to upgrade that thing without some kind of automation. But just know that this is the general way you do it. You want to read the Kubernetes documentation for the release that you're upgrading for. And one thing to know, by the way, you can't leap releases. If you're at 1.16 and you want to get to 1.20, you gotta go from 1.16 to 1.17 to 1.18 to 1.19 to 1.20. You cannot skip releases. That's because they maintain strong backwards compatibility. And when you run through the releases like that, they change the data structures and it makes them consistent for upgrade. So just so you're aware, at that point, by the way, you might as well just install a new cluster, just to be frank about it. If you're going from 1.16 to 120, just install a 120 cluster and move everything over to it, right?
How often do they have upgrades?
It is frequent. It's like once every 3 to 6 months at a minimum, they are releasing upgrades. And the upgrades, like I've only seen one that was insignificant in the last like 5. Every time they release it, it seems like they've released some kind of significant change. Not necessarily like a mutative change, but an additive feature to the equation. So they're on 1.22 now, right? So the releases are significant, actually. Especially just to say this, in the Windows space in particular, the impact on the Windows side is very significant when they release changes, because they're still trying to figure out how to get that to go faster.
So Paul asked earlier about what do you call front end, back end, full stack developer. So what do you call it where you're basically infrastructure as code, configuration management as code, Ansible, Puppet,
I mean, the death of engineers.
DevOps engineer is what they officially call them. I refer to myself as an infrastructure software engineer. That way they know that I can do software, like I can manage Git, I can do Git flow, I can do all the integration tests, I can write unit tests, I can do all that stuff. But I'm focused on infrastructure code. So I can do unit tests for Terraform, right? But if you throw me at Python and you say like, hey, I got all these features in here, I could probably figure it out, but like that's not my strong suit. So I usually say I'm an ISE. I'm an infrastructure software engineer, right?
After that discussion, I tried to Google it a little bit, and it does seem like sometimes job applications are synonymous. Infrastructure, they say infrastructure DevOps engineer, and sometimes it seems like it's more about system admins. So I guess it kind of depends.
Honestly, I wish we would have never left system admin, system engineer, because that's what we did then, right? I mean, we wrote code all the time to make things work faster, better, easier, automated. So, whatever. I understand what they're trying to achieve with DevOps engineering, but just so you know, like the founders of DevOps, even like Gene Kim and those guys, are like, please stop calling your people DevOps engineers. But man, the recruiters got a hold of it. It's done,
Yeah.
It's all good.
It's a popular term.
There's no putting that cat back in the bag at this point. It's out.
No.
Yeah.
So I guess if you're searching for positions, like you have to search for both.
Yeah, and just to say this is like, you can pander to the position, but make sure they give you specifics about what they want you to do. the worst thing you can do is walk into a position and they're like, we want you to do everything. And you're like, well, I'm not really good at everything. I'm good at like 7 things. Which 7 things do you want me for? And then, because then, again, I know sometimes it's like, well, if you're willing to accept that I'm going to suck at this, I'll go solve the problem for you. But typically you're going to be happier if you can stay strong. And when the worst jobs I've ever had are the ones where I was like so excited that I got to do everything. And then I was super burned out because I got to do everything.
Yeah.
You follow me?
Yeah.
It's
yeah.
exciting for the first like 3 to 6 months where you get to do everything, but that's not how you build certainty and expertise. It wears you out after a while. And I love variety, but I can't master 20 things, right?
Oh.
Yeah.
I'm the opposite. I don't like variety.
Then good.
So,
Pick 3
I-
things, get
yeah,
known for those things, and then people will hire you for those things.
From your advice, I think I'm gonna see if I could take an Ansible class and then, Ansible, Kubernetes, and Docker.
Great.
Maybe
That sounds
that's-
like a great start. And by the way,
Yeah.
Ansible can be extended to do provisioning. So even if you didn't want to get into Terraform, you can jury rig Ansible to actually do cloud provisioning and stuff for you. It's not built for that, but it actually does it pretty well when you want to extend it. Okay, let's talk about this last thing that we have in like the last 10 minutes, right? By the way, I want to point out that most of the things that I talked about as far as Elasticsearch, Logstash, and Kibana are on this summary page. FluentD is listed there as well. Only thing that's not here is FluentBit and the Beats thing that I was talking about. Splunk is a third party, and it can be hosted on premise, but it's typically used as a third party now. Oh man, this is a interesting chapter. We could spend a whole day on this section. So Jenkins is a CI/CD server, just like Bamboo, just like GitLab, just like GitHub Actions, right? So you guys are cracking me up in chat, actually. So the main thing to know about Jenkins is that it basically runs in the concept of jobs, just like cron jobs. Basically what it is that you build a job, and that job, by the way, could also be called a pipeline, which is just really a scripted job. That's all it is, right? And what this does, and actually, I think I was messing with this. Hold on. Where did I stick that thing? Oh yeah, I was just actually messing around with a pipeline inside of Jenkins, right? This is all scripted in a language called Groovy, which is literally not used anywhere else except for Jenkins. So don't learn this. Learn just enough to like manipulate this if you want to use Jenkins, but quite frankly, I would use GitLab or GitHub Actions. But let me be clear, the government does not typically support SaaS services, so you might end up using Jenkins just because, right, you got to get something on premise, right? So it's a good tool. Anyway, this pipeline is pretty intuitive to read. Just ignore this line for a second. But basically what it says is that here's some stages. Here are some arbitrary stage names that I made up, which is log, Java, Git, and Maven. Clone a remote repository. You probably know what these mean. Let's check out and do some remote merges, right? Let's compile our code. Let's run some tests. Let's build some artifacts. Let's deploy to Tomcat. So even if you don't know like exactly what all these lines are, you can probably figure it out just from the titles alone, right? By the way, MVN refers to Maven, which is mainly a Java build tool, right? And then of course Git and all that you're probably familiar with. But this kind of scripting, this is what Jenkins does. Jenkins allows you to basically create these pipeline jobs that do a bunch of like cool actions. And here's the cool thing about Jenkins. Jenkins will run anything from the command line that's non-interactive. Just like Docker. Doesn't that sound funny? Just like Docker. So these commands, for example, right here, you see bat, Java. This is actually running on Windows. Because if it said SH, it would be running on Linux. Instead, it says bat, which is old for like batch file, right? What this means is that you can literally run any command that you can run on the command line, you can run in these Jenkins pipeline scripts. And that's all that Jenkins does. Jenkins is an orchestrator. Not a container orchestrator, it's a job orchestrator. It allows you to execute scripts, functions, code, right? It allows you to execute this under whatever time frame you want. Jenkins is also really cool because it can watch repos, watch you change them, and then it will trigger a job because you made a commit to a repository. So if you're using CI/CD, Jenkins is a great tool, but just be clear, Bamboo and GitLab do the same thing. right? They watch a repository. If they see a change, it triggers a response. And by the way, that could be push or pull. So you could have the repo trigger Jenkins, or you could have Jenkins watch the repo. Doesn't matter, right? But that's what Jenkins does. Jenkins is a CI/CD build server whose job it is just to orchestrate simple code execution. Those could be scripts. It could be real code. Doesn't matter.
Question, do you have a like really quick breakdown of like the industry uses 50% Jenkins, 25% Bamboo, 25% GitLab or something like that?
No, I don't, unfortunately. I wish I did. But like, I don't know why, but like nobody really polls for like tool usage across the entire industry. Somebody might have done it, but I don't know how up to date it would be. People don't like
Maybe.
disclosing their tools. I don't know why.
Oh, okay. It'd just be helpful to know, well, if that's the popular tool, then I'll learn that one.
I will tell you that Jenkins is by far the popular tool, and only
Okay.
because of history. I think it's still hovering, if I were to guess, somewhere around 50% utilization. But the other tools are GitLab, GitHub Actions, Azure DevOps, which used to be called Team Study Foundation Server, if I remember correctly, and Bamboo. Did I say that already? Bamboo, GitLab, yeah. And then you've got a bunch of third-party services. So my guesstimate at this point is that Jenkins probably still has about 50% of the market share, which is actually pretty solid. Like that's large, right? Matthew, Blue Ocean, which is a plugin that goes into Jenkins, actually offers a lot more orchestration value because you can directly hook into GitHub, which you can't do like easily or natively with just Jenkins. So Blue Ocean was written as an enhancement by the Jenkins team to make it so it was more orchestrated. So yeah, that. Let's see. That's no longer true, actually. Hudson is dead. Hudson died in 2017. So Hudson was the original progenitor of Jenkins. Let's see what else. So execute jobs based on change in version control, which I just talked about. Time, you can manually trigger it. You can execute anything you can do on the command line, you can execute in Jenkins. Here's the other cool thing about Jenkins, just to show you this. Jenkins has this concept of plugins. Oh, hold on. Oh, sorry. First of all, when's the last time you saw Voltron? I'm just saying. Take a moment, drink it in. Drink it in. When's the last time you saw Voltron? I mean, come on.
Cool.
It's 5 mini lines coming together, right? That's got to be cool. Yeah. So Jenkins, let's say you're like, hey man, I really want to basically add some AWS functionality to my Jenkins server. Guess what? Jenkins has tons of plugins written by vendors and by the community that instantly extend the functionality of Jenkins. Now, some of these plugins are abandoned. So when you click on them, please make sure you check and see that they're actually still being maintained and maybe updated within the last 6 months, just to say this, right? If it says it was released and updated, like, I don't know, 2 years ago, you probably want to avoid that. And Trevor, that's a good point, because I've actually taught classes on this, is that Booz Allen has a Jenkins templating engine that they wrote. They actually published a book on it as well for extending Jenkins and doing installs. I want you to know that templating engine is not for the faint of heart. Okay. You need to be a programmer to really love that thing. Okay. But once you learn it, it is a very powerful tool. Right. My point being, though, is that you come out here and say, hey, can I integrate with Azure? Yes, you can. Can I integrate with GCE? Yes, you can. Well, maybe if I typed in the right thing. Right. You can. Can I integrate with Kubernetes? I feel like this is like a yes, you can kind of like moment, right? Which I like, actually. Anyway, Kubernetes, right? You can do that. You want to integrate with Docker? There's a Docker plugin. You want to integrate with Ansible? Let's go take a look. Is there an Ansible plugin? Ooh, there's one for Ansible playbooks and for Tower, right? Are you a fan of Puppet? Okay. Now, again, remember my caution. Make sure you go in and check and see if this thing's been updated in the last whatever, right? Okay. So Main thing here with Jenkins is that this is a build CI/CD server. You can build anything you want as long as you're either willing to run it on the command line or you got a plugin for it, preferably both. So Jenkins, by the way, can run in a variety of formats. This is what the web interface looks like. I'm just going to go past this because you don't need to know how to install it. You can do it. You can look that up, right? Nope. This is one of my favorite views of Jenkins. When you define jobs, check out, build image, activate project, what it does is it actually creates those titles for you. And as it runs through all your stages, it will tell you the status. Green is good. Green is good. Yellow means that you skipped a test. And so it's a little weirded about that. Yellow means it failed. If you hover your mouse over that, over a red one, it will tell you what the error message is. It's pretty solid. Jenkins plugins can be installed straight from Jenkins. You don't have to go to the website, by the way. There's a section in Jenkins to do this. And that's pretty much it. So bottom line, go ahead.
Jenkins output functionality when when a job runs is golden. You don't see it on any of your pictures, but that's where I live, is in that output.
Yeah, let's see. Let's see if my server's running.
I will say for the output, the Blue Ocean stuff is really nice because it breaks it up into chunks and stuff. And like, and sometimes we'll put test on its own little tab and things.
Yeah, but be honest there, Jonah. You were living in a world of text for quite some time, swimming, trying to figure it out.
Oh,
All right,
yeah,
not for the
it
faint
was
of heart.
painful. It was painful.
All right, so see this? This is a bunch of jobs that I have running for a variety of different reasons, right? This is what Jenkins looks like. Now, don't get me wrong. This is Blue Ocean, which, by the way, makes this prettier. See this? If I click into one of these jobs, by the way, take a look at it. It actually will show me the status of the different runs. If I click on one of the runs, it will literally break it down for me if there's been any details on it, which that one didn't have any details. That's kind of horrible. Let's go take a look at another one. All right, see this? See these little stages right here? All green, looking good, right? If it runs into any problems, by the way, it just shows them up. But notice this whole thing is green because it actually did exactly what I wanted it to do, right? So this is what Jenkins is that this runs locally on a server. Usually most people access it through the web interface. You can use the Java API. But this, and by the way, if it's thunderstormy, that means it's failed a lot. If it's sunny, that means it's succeeded all the time. If it's got clouds on it, it's like, eh. And if it's got like this, then it's like, eh. And if it's got the lightning bolt, then, you know, something bad happens, right? So it gives you the overall health or around the history of the system. If you want to add plugins, by the way, all you need to do is actually just go into like managing Jenkins. By the way, this one's a little out of date, but you can literally go to manage plugins and it will allow you to search for any available plugins. So remember earlier that we were looking at Docker, right? You can just search from directly inside Jenkins and find what you need, okay? So my recommendation is that there's a great lab on running Jenkins inside the system. You got a whole week to do this whole thing. And so my recommendation is that you come in here and you kick the tires on Jenkins. Now, I want to acknowledge that it's 4:32 and I want to be mindful of keeping everybody past the time. Here's the deal. So first of all, are there any questions about this? Because I know we ran through it pretty fast. Okay. So here's what's going to happen from here. And I'm going to throw this out there and then I'd love to hear any feedback because I actually also have to post evaluations. So I'm not even sure what I'm doing. Your feedback is going to be crucial for me to be able to get this class fixed. So please, you know, be respectful, but don't hold back. You know what I mean? Like, let them know that like things were a disaster and garbage and all this other stuff. Just like, you know, let's be frank about what happened here today. You guys were very gracious about it, but this did not go as perfect as we wanted it to. So, you know, and I'll be fine. So just, you know, just let them know so I can actually like push on them a little bit. All right, so I'm going to post the evaluations for the class, but before I do that, here's what's going to happen. One, within the next 24 hours, you're going to get an email from me that's going to include everything that I took notes for as far as like the things you were asking for. Like I saw some of you were asking for good CI/CD recommendations for classes, YAML recommendations for classes, other Kubernetes classes, Ansible classes. What was the other thing? Ansible, other like Docker things that might make sense. So I have a list of that stuff. I have a huge list. So I'm going to give you access to that, including some of the workshops that you can do that are Kubernetes specific that you can just do on your own. I'm also going to list the next class that you should probably take if you're interested in going after CKA. Okay. The other thing that's going to happen is that these machines are going to stay up for a week. So you've got a week of unfettered access. And when I mean a week, I mean end of day next Wednesday, not like 8 a.m. So you got a whole week to just go kick the tires on this whole thing. You're not going to run into any image backup problems because not everybody's going to be working at the same time, and Docker's going to release their hold and stop freaking out. The other thing that I'm going to do is that when I send the email, I'm going to ask for your Amazon email address. And what I'm going to do is I'm going to gift you with 2 of the best books on Kubernetes that I can give you. And I'm going to list them out in the email. And if you come back to me and say, you know what, Michael, I don't want that second book. Can you get me this book instead? We'll do that. Okay. So I'm gonna make sure you have good information to chase after this. So not only will you get training information, but we're going to buy on Kindle for you 2 books, the best books that I can find on Kubernetes, which I already know what they are, but I want to surprise you. Right. So I'm going to give you some good books on Kubernetes that can take you to the next level. These will be for beginners and one for intermediate. So I'm not going to give you expert books because none of us are there yet. Right. But I'm going to make sure that you get that gift. You know what's funny? There are no good
We're
books
not
on
experts
Jenkins
after
anymore.
3 days.
Say again?
We're not experts after 3 days.
Well, you know, you just need like 4 or 5 days. Maybe if the labs had worked, you guys would be experts by now. No, yeah, you need, like, obviously you need a little time. So that's what's going to happen next. If, you know, if there's anything else that we can do to help, support, guide, or assist, please let us know. Otherwise, I think that's what I'm going to do. Your feedback is super welcome. Here's the evaluation. If you can fill it out, great. Otherwise, I will also email you, and I'll make sure the evaluation link is in there if you're like, I got to go, right? So I'll make sure by tomorrow morning you have the evaluation link. You can always fill it out later if you want to, okay? Otherwise, just know that it actually has been a great pleasure, despite this like sometimes weird stress that we've kind of gone through with the labs. This actually has been an engaging class and one of the more fun classes that I've taught. So, you know, it is what it is. We just have to adapt, okay?
Will you get a download link for the lab VM that we use?
Actually, yeah, we can provide you a download link if you want the lab VM. That's not a problem at all.
Because I mean, instructions to set up a Minikube installation is good, but having the exact same environment that we use, that the lab instructions were designed for, would make things work that much better.
You got it.
Yeah,
And
that
I
was-
think
Preferably with fixes applied to the VM. Fix the problems that were encountered.
now that I can't guarantee because those guys take a long time. So if we wait for that, that's going to be weeks away, right? Just so we're clear, because their process just takes a long time for them to get to like to generate those kind of files. What I can guarantee you is I can give you the entire solution set. I can give you all the files that were on the VM and everything that was in there. And I guarantee you, if you just run Minikube, because there was nothing else special about the installation, there was not a single thing. You could literally get the solution files, run Minikube on your local system, and it would work fine. But I'll get you the solution set. If we wait on them to fix the VM, that's going to take weeks, right? I know that sounds weird, but they're backlogged and there's other things going on. So, yeah. What was the other request? Oh, I just missed it. Lab VM. Yeah, that's it. So Elliot, Ubuntu rolled out Snap a little while ago. It's caused a lot of contention in the community. I think it's a great product, but it kind of ticked off Linux Mint and a lot of the derivatives. I'm sure, Trevor, you've probably seen that as well. So not everything's in Snap, but the things that are in Snap work really well, actually. Okay.
How is it better than apt? I mean, assuming that can be described in a sentence.
Yeah, Snap is exactly like apt. That's all it is.
Okay.
It just has a lot. It's not newer, cleaner, and faster, honestly.
Okay.
All right. So then technically, we're done. I'm gonna let you go because I want to be mindful of time. I'm gonna hang out here for a second in case anybody has any questions. But technically, this is the official end of class. You guys have been amazing. I will include the recordings in the email as well. So you'll have all 3 days of recordings. This will be on YouTube. It's up indefinitely, right? So you'll have access to it for as long as you want to. Other than that, just let me know. I'm gonna go ahead and post my email into chat, but you'll also get it when I send you an email. It's michael.forrester@webhsolutions.com. I am a contractor for WebH, so but you can always reach me there. Let's see, checking on one more thing. Yep, Ansible is already on the list. Paul, I would say, oh yeah, sorry, echoing what Trevor and those guys said, Ansible is definitely the next thing. Jenkins is so easy to use and so use case dependent that Ansible is going to be a lot more useful tool for you. Jenkins, like you could walk into an environment where they use Jenkins one way or Bamboo. I've touched all 5 major CI/CD systems in the last 5 years. So I would stick with Ansible and then add Jenkins in later.
Sounds like we're fucking or gasping for like drowning.
Not sure what that was exactly. Anyway, thank you again for attending class with me. This is the official close of class. I will stop recording. If anybody needs anything, I'm going to hang out here for a second. Otherwise, we're absolutely done. And thank you for hanging out with me for 3 days.